Hello and welcome to Schmidt Ocean Institute's live feed. We're currently conducting dive 231 in the Guaymas Basin area. Hello and welcome to Schmidt Ocean Institute's live feed. We're currently conducting dive 231 of remotely operated vehicle SuBastian. We're currently diving at the Guaymas Basin. The vehicle is currently at 2,011 meters. We're just several meters off the seabed and the pilots are getting the vehicle ready to descend down the last few meters and commence our mission. Today we'll be recovering some experiments and deploying some other experiments, including the frame you see on the vehicle in front of you, which is the silver frame, and on that is dozens of temperature probes. Also on the front of the vehicle there's a number of push cores. We'll be taking scientific samples of sediment today and collecting mussels. We'll be operating around a number of hydrothermal vent sites today, so stay tuned. There's going to be some amazing footage.
Morning. We're going to step you down to the southwest in increments to get us in a position so to see the new waypoint.
The voice that you hear will also be the communication of our bridge.
Thanks, sir. Thanks.
Bridge, so you're aware, you probably hear us, that you're also live on the internet, just so you're aware. Okay, if any of you have any questions, as we're live on YouTube and Facebook, feel free to ask. We've got a control room full of experts here who can help answer them. Just ask away. We'll do our best to answer them. Okay, for your information, we're currently at 2,014 meters. Our team are just getting the ROV settled. We've just spent the last hour descending from the surface down to the seabed. At the moment, it's around 2.9 degrees Celsius around the vehicle. In a minute, we'll head off and start our exploration of this area. At the moment, our team are just going through some checks. This live feed is coming to you from Schmidt Ocean Institute's research vessel Falco, which is currently in the Gulf of California, a location called Guaymas Basin. For those who just want a rough area, it's 27 degrees of latitude north and 111 degrees west.
These are correct. And there's right in the middle of these. So
At the moment, our principal scientist is just coming up for some waypoints for our ROV team to go and explore. Okay, sorry about that. We were just offline a sec. We were just debating the plan, and now in a moment we're going to head off and start exploring.
Can I see the questions over here? Okay. So hey everybody, we are on our way to our first sampling target. We're in a site in the southern trough of the Guaymas Basin in the Gulf of California. This is an area impacted by hydrothermalism. There are hydrothermal vents. The vent fluid seeps up through the sediment, and as we transit across this fairly boring part of the seabed here, this part doesn't have hydrothermal overprinting. You'll see a pretty stark transition here in a little bit when we head towards the vent field and on top of the vent field. You'll notice there's a lot of particles in the water. Those particles are microorganisms that feed off the energy coming out of those vents and become quite abundant in the water column. It's one way that you can tell when you're headed towards an active area of seepage, is that you get a pretty nice particle, a pretty serious uptick in the particle field. So we are how far away? Yeah.
I have a question for you.
Yep.
Would it be possible to do that plan in reverse and actually go up to and drop that sampler off first? Because that way we can
Yes.
get that. We can do
Yeah.
that way?
Yeah. We could do that way. If you want them to pull.
That way we could get that out. We could shut
Yeah,
the
yeah,
things
that's
or
fine.
the shadow.
Yeah, it means we can yeah, it's
If
no
it works
problem.
for you, though.
James, do you want me to hold there or keep heading southwest?
I'm gonna stand by over
You
here.
can hold position there, stand by. We might have another.
Well, how big of a can the ship basically tow the vehicle, or is it the vehicle moves under its own power and the ship's just following it?
Yeah,
Pretty much.
Yeah.
Okay. So the problem is the osmosis sampler location is where we need to drop that that instrument.
Okay, so that's 250 meters. We can transit there pretty quickly. It's not just scoop across.
Okay.
It's not like road.
Okay, then let's do that.
We'll speed it over there.
Yeah. Yeah.
It would give you a lot better.
Yeah. Yeah. We'll basically drop that off, scoot down there, and then just do the reverse pattern and end up where we started. Yeah. Oh, can you grab Jesse? Because I told her we were going to do this afternoon. Jesse? Yeah.
Hello everyone. Just for information, what we're going to do is do a 250 meter transit from our current location so we can deploy the experiment, the silver box that you see on the front. The reason we've decided to do this first is because our lights are dazzling off the actual frame of this instrument. Once we've deployed this instrument, we'll then do a video transit. Having this box on there while we try and do that will throw our cameras off. So we're going to come off the bottom and transit to that site. So it'll be a short amount of time, then we'll deploy this experiment. And then we'll start our video transit through the vent field. If anyone's got any questions, feel free to ask them on our social media feeds. You're joining us from Schmidt Ocean Institute's research vessel Falco, currently in the Gulf of California. We're at 2,000 meters of water. Stay tuned.
Yeah, if you can speed over there as quick as you can, we'll try to keep up again.
Cool, so that's just directly north of us, yeah?
Yeah, it should be
Okay.
about 100, 250 meters.
Okay, I will zip over there.
Okay.
Thanks.
Cheers.
If you want to just keep him south of you until we start.
All right. So there's a question about what kind of instrumentation has been deployed and how long has it been deployed. We deployed back in November, around the 28th or 29th of November, we deployed osmotic pumps, these very large osmotic pumps on the seabed with coils of tubing. And what they do, they basically pump water at a very slow rate from the sediments and store the water in copper tubes. And over time, we put out about, I think it was around 500 feet or so of copper tubing. But over time, that copper tubing gets filled up with fluid by the sampling. So what we can do is take it back to the lab, cut it into pieces, and we have a time series record of methane concentrations and CO2 concentrations in the pore fluid. So it gives us a way to get in situ concentration fields over long periods of time. And this deployment, which is now around 3.5 months, is one of the longest ever in a hydrothermal environment, and certainly the first that's ever been done in the Guaymas Basin. There was another question from, who was that question from about the bacteria? From Kathy, about what kind of bacteria are we researching, and do they anything to do with marine life's beaching themselves? So we are working primarily on heterotrophic and what's called chemoautotrophic bacteria. So these are essentially all the organisms that use energy from either sourced from the hydrothermal fluids or sourced from the natural organic matter in the sediments. So we're really interested in studying the organisms that are present in abundance, like the sulfur bacteria, but we're also just interested in community composition and community diversity in general. Most of the organisms that we are working on are not noxious organisms. They're not the kind of organisms that cause, they're not pathogens. They're not going to cause any kind of disease in marine life. Quite the contrary, some of these organisms have relatives that are closely related to the symbionts of, for example, the tube worms that we find in these areas, the riftia. So the microbiology of these areas is really fascinating. It's not very well described in terms of community composition and complexity. So we're really looking forward to finding more.
Cool. That's all the questions.
All right.
Someone else then.
So we're dropping it off first. It's causing a big flash, so they can't. Yeah, because they can't see. This frame is just causing an issue with the lights. So we're gonna drop. We're headed back up there now to find a place to drop it off.
Okay.
So
We're about halfway there.
yeah.
Andy, a few people are asking what the silver box actually is. So if you get 5,
Yeah.
just explain what the frame is.
So the large frame at the front of the SuBastian's basket is a lander that contains on the bottom. If you look through the frame, you'll see there's a grid on the bottom, and there's a bunch of little dark colored circles. Each one of those is a temperature sensor, and those temperature sensors are placed at about maybe 2.5 centimeters, 3 centimeters a piece. So we have a whole grid there. You see, they're all tied down. So there's a whole series of these temperature sensors. There's 5 rows, and we're going to place them down on the sediment. And what that'll give us over about a week-long incubation is a time series of how the fluid is flowing out of the seabed at different rates and at different temperatures. So that the heat flow is really a good proxy for hydrothermal fluid flow. So by tracking the temperature in a really sensitive way, as we can do with this instrument, we can actually get a feel for variations in fluid flow. And we're going to position this thing over microbial mats that are different colors. We have this hypothesis that the orange mats like really high flow and high sulfide and high temperature, and the white mats, which you'll see shortly, like lower temperature and lower flow. And by putting this instrument at the boundary of a white and an orange mat, we can test that hypothesis.
So, do you guys want to do any cores around the mat? It might be.
We are We shouldn't be. We are not quite there yet. So now we're coming up to a microbial mat field. That's a nice one right there, Jesse.
Nice.
Hello, can everybody hear me? Excellent. Okay, well, welcome aboard the research vessel Falcor. And it probably looks a bit like a sort of spaceship situation going on here. This is the control room where we control the ROV SuBastian, who is down on the first science dive of the expedition. So yeah,
Wow.
yeah, it's pretty cool, isn't it? So we've got the pilots and the co-pilot in the back over there, and then this is the chief scientist from the expedition, Mandy Joy. Ooh.
Hello.
Give everyone a wave.
Hello.
Wave goes hello, yes. So yeah, we're gonna go through and show you.
Wow.
Yeah,
Got a nice bacterial mat.
Is that all
So
mat
I
over
don't know
there?
if you can see this here. This is what we're seeing live.
Yeah.
We're 2,000 meters below the surface of the ocean, and this is the kind of stuff we're discovering right now, exploring these microbial mats that feed lots of the ecosystem down there. Yeah, it's pretty cool, isn't it? You know, can you
I
imagine
think let's
hanging out
just
in
fly
here?
over and
We're
not,
in here
because
for like
you can never
14
tell
hours
when
a
there's
day.
a
It's
vent
quite
under
a
you.
long stretch.
It's, I mean,
But,
unless you're in
everyone's really excited to be on
rather
this.
boring sediment.
Shall we take you
Okay.
through to the control room, or do you want to
Yeah.
do some?
Let's see if we
Sure.
can.
Did you want to?
take it
Those,
from here, control
Okay.
There's flotation on those boxes that should give you
Hello,
a radar
everyone.
reflection too.
Okay, yeah, we're looking there.
Should I be able to hear them?
Yes,
Can everybody hear me?
They're kind of a poor person's radar reflector,
I
but
don't hear anything.
It should be someplace.
yeah, we got them on the Alvin when we were looking for them.
Oh, there we go. Now,
That
can you hear
mat
me now?
over to the port, Jesse, is looking, that's pretty good.
Oh, great.
Yeah.
Maybe we'll walk through the control
Yeah.
room and we'll just take a look at some of the monitors here to show you what the pilots are seeing.
Oh, that's very nice.
So this is all real time.
This is
This
excellent.
is our very first dive,
This is an excellent spot.
and you can see we just got to the bottom and we see all these microbial
See that
mats.
transition between
They're
yellow
very
and orange?
interesting. We've got yellow and white microbial mats. These are called Edgiozoa. And as Tom said, they form the basis of much of the food chain here. And maybe Tom go up and show kind of where we're at. And what we're going to do is we're going to drop off a sampler, this very first waypoint here, and then move on to collecting various organisms and some sediment to examine. We'll bring all those back up to the ship and be able to examine the chemistry and the biology of what's going on there.
Those little towers,
Yeah, they look like shadows there.
Did you want to
Jason,
go?
those are the little oil towers. You see those little
Oh.
towers there?
Sorry, what are
Do you
they?
see those towers? Those are the oil chimneys.
Oh,
Those
okay.
are little oil
So
chimneys.
yeah, there's something interesting that's just now coming up. We've got oil chimneys. They're a little hard to see from this vantage point, but they're chimneys that bubble up the venting fluid and some of the oil that lays beneath all of this and supports all of this biology. All right.
Yeah.
You want to head to the library and we can do.
Yes, maybe if you can.
So let's not sit on those chimneys. I think the lander is Dan on,
Oh, okay.
Jesse? Do you know if Dan's on?
He is available.
Hello, our scientists are just debating some of the bacterial mat that they can see at the moment. We're debating where to put one of our future experiments. We're currently still transiting to deploy the temperature experiment that we've been talking about. It's that silver frame that you may see in the image. On this frame is a number of temperature recorders, and we're going to put that over some venting fluid and get a real good understanding of the temperature flow. We're currently at 2011 meters. This live feed is coming to you from research vessel Falco, operated by Schmidt Ocean Institute. Our scientists are getting pretty excited at the moment at the amount of bacterial mat that they can see. See if I can there's a lot of activity in the background at the moment as they debate about where to deploy the experiment. So the debate that's going on in the background at the moment is that they want to put this silver frame onto the border between the two different coloured bacterial mat that we see.
Can you get it out? I'll sit down and see if I hope everyone can show it. Alright.
There's usually enough current on the bottom that it's not so bad.
I'll try and get our principal scientist in a moment to answer some of the questions that have come up on the live feed. Just a little bit of background information while we get ready to deploy the experiment. Overnight, research vessel Falco used a deepwater multi-beam system, an EM302, to map around the site where we're currently deploying SuBastian. During that survey, we identified some of the plumes around the area we are at the moment. But we also identified a large plume coming from a hydrothermal vent almost 2 kilometers away from this feature. This plume is substantially large, bigger than any around the existing known vent field. So hopefully tomorrow we'll visit that site, and also we should have some more cool video for you then. At the moment the vehicle is now landed on the seabed. Our pilot and co-pilot are talking about the best way to deploy the frame onto the seabed and where exactly to put it. At the moment you can see one of our manipulator arms. I will change images. So at the moment I've just changed images so you can see our starboard manipulator arm. This is a robotic arm controlled by our co-pilot, sat next to me in the control room. He is using a master controller. This is basically a replica of the arm on the vehicle, and when he moves this controller, the arm subsea on SuBastian mimics that movement. Now that controller also has buttons to open and close the jaws and rotate them. It takes a lot of getting used to use these manipulators. After all, SuBastian is currently 2 kilometers below us, but the messages traveling to and from the vehicle are traveling over several kilometers through our umbilical. There you can see our port arm is actually being used at the moment. These arms are incredibly strong and surprisingly dexterous. They can lift quite a few hundred pounds. And our co-pilot has to be very gentle when lifting these, as the arms are incredibly strong and could easily crush the aluminium frame. There you see the jaws opening. When this is going on, the control room is utterly silent, and everyone's sat here with bated breath. control room at the moment we have our principal scientist, Professor Joy, our pilot, James. Chris is operating the manipulators. We've got our technician, myself, maintaining all the data. Each of these dives produces many terabytes of data from numerous sensors on the vehicle. At the back of the control room we have additional scientists who are logging events and keeping a dive narrative. This mission, first of all, is to deploy this experiment, and then we'll go and have a explore around the vent field. During this exploration we'll take samples, including sediment samples, and also pick up biological samples, mussels, that will be placed in the bio boxes. All this equipment is stored on a retractable tray on the front of the vehicle known as a basket. At the moment the basket's fairly full, especially with this experiment. Once we've taken this off, it'll be a little bit easier to work with, and one of the reasons we're deploying this first. These images are coming to you 2,013 meters below the Gulf of California.
Oh, genius, Russ. Yeah, I'm gonna grab it. Now I'm just gonna try to take it up a little bit, bring it back. Alright, totally clear. Just gonna use the corner of the arm.
Oh, okay.
I can't quite get it in. Alright, that's there. Next one out again.
Okay, so our co-pilot's switching between the arms. He was just using the starboard manipulator. We'll go back now to using the port manipulator.
That's pretty good. There's an arm right there.
So we're now lifting the experiment off.
Alright, so we're going to go straight out, find that interface between the white and the orange, try to position it so that the half of the sensors are on the orange and half are on the white.
So Professor Joy is just
Shadow is on this.
talking with our pilot and co-pilot. They want the sensors placed on the boundary between the white and yellow bacterial matters on the seabed.
No, I mean further forward. Yeah. Yeah, further like right there.
Does that got white under that?
It does. You look right there. That's some white.
Yeah, we want to get that
Oh,
edge
more of it.
of
More.
that edge.
Yeah, I got to jump up. You got to go forward. I can't quite reach it. I'm not frozen. I am frozen.
Okay, so turns out the area the scientists want is just a little bit too far to reach. So our pilot James is going to lift the vehicle off slightly, nudge it forward, and then we'll carry on deploying the experiment.
There are worms on the outside of the orange. Really? Well, I don't know if they're worms or
What's that yellow stuff? Gently, gently. That's pretty good right there. I should do that. Sit down.
As you can see, the sediment here is very fine.
there's a good current there. It's moving out of the way.
From the moment we settle on the seabed, kicks up a little bit of the dust. Just wait a moment for that to dissipate, and then carry on with the deployment of the experiment. The white grill you see at the bottom of that aluminium square contains dozens of temperature sensors that will be able to profile the heat around this bacterial mat that you're seeing.
We're sure we're got ample coverage in the get that middle line right on that edge, that would be perfect. Not that I'm asking you to do something impossible, but
I think we should be alright.
a whole,
Do you want us to push it down into it?
Yeah,
push it down.
so
Not
Happy,
very
happy?
far down, but just a little bit.
You happy
Yeah,
with
that
that?
looks good.
we
That's
need to
good.
mark the time. What time is it?
Tell me when.
1446, go. Keep going, keep going, keep going, keep going. Stop.
Alright.
Now, if we could get, he's staying on the line. Maybe get him to look and see if that's far enough down.
Well, let's see. It needs to be, make sure the sensors are pushing into the line.
They're definitely pushed down. I was getting pushed back.
Okay, and we need to put weights on it. So the sensors are like covered in the button?
They're not covered, they're into the unit.
Alright.
We're just currently looking.
We don't have any, and I think we can pull them out of
We're
our
currently
line.
looking at the experiment on the seabed,
I don't think it's going anywhere. It's heavy. Let's let go and see.
Wanna go and see what happens?
Yeah.
Guarantee it's not going to float.
there's no buoyancy on it.
When we come back and pull the osmos, we can take the plates out of the osmos and sit it on top.
Yeah, 'cause I wanted those sensors like in the mat. I still
So you want to
see
push
them.
it down? Okay,
Yeah.
we can push it down more.
Yeah.
Push it down more.
Push it down.
Can you take the arm and put it in the middle of the floor? Push it right down in the center so that it's evenly buried.
Yeah.
Yeah, if I push on that.
Sorry for going off air there for a second. We were just debating the best way of deploying this, so if we needed to push it further into the sediment. One of the cool things about working on research vessel Falco is we can quickly pull in the people ashore whose experiment it is and discuss with them. So we were just off our live feed chatting with our scientists ashore and figuring out if the current placement of the experiment meets their needs. Currently the co-pilot is operating the manipulators and is gently tapping the experiment to make sure that it is fully in the sediment.
It's pretty solid pushback. As soon as I let go off, push it down, push it back up. So.
Justin, can you tell him that the one thing I want to make sure of is that we're not on the press. Make sure we're actually getting flow. So if we're going to do it, can we do the heat flow probe, try the heat probe,
Other than that, it's
maybe to either side of it?
just deploying this template back, taking out the road, because carrying it around all day is not what we do.
Go, go.
So charted in there, so
we
she'll
got
tell
it
me where
all
to go
good.
next.
Yeah, ready to recover.
We are down, still on, a little bit dark down. You have to play the lights to get the lights dark all the way up. It's very soft. Yeah, it's not a big activities. Probably light. A little bit light, but not ridiculous. It'll be free. When I had it, I checked it.
The moment in the middle of a pilot changeover, change of watches. I think in a moment we'll probably use the ROV's heat probe to take temperature readings around the experiment before we move off and continue our exploration. If any of you have questions, feel free to ask them on our Facebook feed. We've got all the experts in one place at this time, and they're not going anywhere, so feel free, ask away, and we'll do our best to answer your questions. Ooh. Okay, we've just got confirmation from our shoreside scientist, and they are happy with the placement of the experiment. At the moment, our principal scientist is just explaining to pilot and co-pilot that she'd like to take some temperature probe measurements around the experiment.
Yep. So we've got Mr. T, the temperature logging lander, settled on the seafloor, right perfectly positioned between a white and an orange Veggie mat. And now we're just going to take the temperature sensor and make sure that we've got soft substrate underneath the array, as opposed to mineral crust that might make fluid flow difficult. This is a really impressive area. The microbial mats around here are quite luscious. High rates of temperature, high rates of heat flow coming out of the seabed here. Very, very active environment. Temperatures are likely to be close to 100 degrees Celsius within 10 centimeters of the surface. You know, it might be a little deeper, but yeah. What was that reading?
This is 10 degrees Celsius.
Okay.
The highest it was 13.
All right. That's on the outside of the mat. So let's see what it is.
That's reading quite high, the temperature probe, just at the seabed, 12 degrees.
It was in the seabed.
Yeah.
It was in the mud. So where do you want me to put it in at?
Maybe a couple of feet on this end of the,
Like right about here?
closer to the mat.
So
Yeah, keep going. Right there. Do you still have control of this camera? Yeah. Yeah.
I'll be around, so I'll explain it.
So, how do I record the highest temperature?
What about here or close?
Yep, that's good. We might do one more, but let's start here. And how far down does that go? Okay. So the temperature probe is in the sediment about 6 inches down. It's around 15 centimeters or thereabouts.
10 degrees Celsius pretty instantly. 11. See it up there.
This was, when we were settled there, was reading about 12.
I got some white mat just to the left of the arm.
Yeah, maybe go up into that orange. The orange, a little bit closer to the lander. It should be hotter at the closer that you get.
Now you'll see here, high temp reading as well, like that. We keep doing that, and then you keep refreshing it. They're going to measure somewhere else.
And then, do I take a,
You can take images in between. It's a good idea to just go wild. The more you log, the better for you afterwards. And hopefully at the end of this dive, this will update. He can look at it. He'll have the images.
We're at 14 degrees Celsius.
It's not hot enough. That's not hot enough, is it, Jesse?
14.
For what? I don't.
Does he care how hot? I mean, I would think that he wants it to be pretty hot.
15.
And that's at 15 centimeters. It's not at the surface.
I think he's.
Maybe check that white mat over to the left.
Yeah, take that one.
See what that looks like.
Yeah. Just keep hitting them like as you get higher ones, and it's all geotag.
Sorry, I'm like talking to Dan, and then all right. Should I ask him if?
Yeah.
Okay.
If he wants super hot, then we need to move it. Maybe. Because it doesn't look like this is very hot.
Got 15, 17, and 11.
Yeah, for reference, at some of at the sites where my osmos are, it was 80 degrees at 25 centimeters. At the surface, it was around 16, 17. So this is pretty cold compared to some of these more active mat sites. But clearly there's energetic juice there, just not so hot right now.
Want me to test somewhere else, or let this one stabilize a little bit more?
Let that stabilize while she's talking to Dan right now on the phone.
Yeah, I think he can't log into the Facebook feed for some reason.
Huh.
So. Well, he doesn't have Facebook. He's like a rebel.
He doesn't have Facebook. Well,
Yes.
try YouTube then.
The YouTube link is on Twitter.
Okay.
How do I actually see people's comments before that? It's already popped out. Right, so that right.
Ah, okay. Look, Daniel, look. It looks excellent from here. Thank you for finding such a great spot. That's what Daniel.
Can you ask Daniel
If the
about
temperature is okay.
the temperature?
What are you at the moment?
How was that? 19?
20?
19.
Dan, right now the temperature at the surface in the white mat is 20 degrees C. Is that hot enough for you, or you want us to reposition and try to find something hotter? It's evenly positioned, and there is an array of sensors right at the orange-white interface.
Oh, there's like snot bags that he's left. That's what I wanted to get him. Disgusting. It's like Dennis Nedry in Jurassic Park.
That's a really good analogy.
I don't know. Who's that? It's John's.
He said that's okay with me. 20 is about what I expected in white mat.
Me neither.
He said that's what he expected.
He expected a white mat?
Expected.
Yeah.
That's what he expected.
Seems happy with that.
Yeah. We don't know what the orange is, but
Should we sample it? For orange?
maybe we could go over to the right.
So you don't think it's like the Friday orange?
Nothing was really
Yeah.
behaving according to historical precedent in November,
Yeah.
so I don't know. I mean, the orange should be raging hot if the white is 20.
Yeah.
What's that?
Let's ask Stan.
What I can say is,
white balance look like?
He says he likes the spot good in the face and it's interested in the orange yellows on the outer flanks of the map. He seems happy.
Okay.
Yeah, I wonder if it's like a silhouette instead of a utility mat. The orange.
We'll try to get a close up.
So you want to take another temperature?
Yeah.
Is that just to the right of the box?
Yeah. Perfect. Yeah.
Yeah, let's get it. Maybe try the white mat.
Yeah, that's matte. Look at that, Jesse. That's matte.
I was.
See that?
Yeah,
That's matte. That's. It's not.
interesting.
It is very interesting.
So they're.
Do you want the 4K camera over here?
Yeah. Let's get the 4K over there.
How are you finding that? Is that easy to type? Like, do you do a lot of vlogs?
Oh yeah, that's better.
Is that okay?
It would be a lot easier if I wasn't like texting Dan every. Yeah, I'm trying to like do.
Perfect. See what that looks like.
Multitasking here. But yes, it's good.
Okay, at the moment we're currently taking temperature measurements around the experiment. Our scientists on board Falco are using the ship's internet link, not only to stream this to you, but also to speak with our scientists shoreside, who are advising on the placement of this experiment. Now we're all happy with the experiment where it is, and at the moment our team is just placing SuBastian's temperature probe at various intervals around the experiment. We're measuring temperature readings. Currently the sediment is around 20 degrees Celsius. Our
What
shoreside
I'd like to do before we head back
scientists are happy with
south
this.
is
The
to
gradient and the
fly
location
over
of
the
the experiment is
Osmos
good.
and get some good video before we just, you know, should be right ahead of us. Yeah. Let's hope they haven't been consumed.
These
by
images are coming to you
hydrothermal
from
flow.
research
That
vessel
would be
Falco,
a bummer.
currently conducting science in
Yeah.
the Gulf of California. The vehicle is currently at around 2,030 meters depth. Sorry, 2,013 meters depth. I've got a request from Dan.
It's
Can you? It says Dan says,
he
can
has to
you
pull it
zoom
up
in
on here.
tight where the T probe is? Oh, when you put it in, I think he wants you to zoom in on it.
Zoom in on our temperature probe?
When you, yeah, he said, can you zoom in tight where the temperature probe is?
I'll just put it right at the base of his little toy.
He's probably on a delay slightly. He's probably talking about when you were putting
That's
it
probably
into the
good.
sediment. He's curious on what the mat looks like between the interface. So one of the good things about science in the modern era is that we can speak with scientists aboard. Falco's a great research ship, but like with most ships, she's limited to the number of scientists that we can take with us. So using the satellite link from the ship, we can communicate with scientists ashore and actually expand our expert input to whoever wants to join the feed. What you can see in that image at the moment is the edge of the silver experiment, and in the bottom left, the probe entering the seabed is SuBastian's temperature probe. Now we're currently reading temperature values. I'll tell you exactly what the value is. Stand by.
Okay, we go put the certificate broke away.
Yes, let's bring it away. You know what it looks like? This may sound like a totally nerdy explanation, but it looks like core packet, column packet. This little, doesn't it?
Looks like our maximum temperature reading was 24 degrees. Most of the readings around the experiment are around 15 degrees Celsius.
You want a core sample, you said?
Yes, we're gonna take one core in that orange area.
So now that we've measured the temperature at various intervals around the experiment, the next job is to take core, so sediment samples around there. These will be the tubes with the black loops that you see in the image in front of you. Pilots will take one of them up now, insert it into the seabed and extract a sediment sample. This will then be brought up on SuBastian and processed by our scientists on board the ship.
You want an area that has white and orange?
No, one white and one orange, separate. This stuff is, look at the orange to the top is very different from the orange that's right under it right now.
You want some of that?
No, let's just, I want to see what the lander is on. I'm not quite sure exactly what that stuff is. It's probably going to turn out to be Vegetoa that we can just talk. Stream of consciousness, yeah. There's some really spectacular microbial mats here. What you're looking at right now could have been a scene from billions of years ago on the seabed or in the shallows. Primordial energy fueling microbial production at the seabed. It's pretty amazing to see it in action.
Did you see the black bubbles right there?
The oil bubbles, yeah, yeah. This site is oil everywhere. You know, this is one of the, if not the only place on Earth where oil is forming in the modern day through thermocatagenesis. This oil is modern. It's 5,000 years old. It's not like typical petroleum, which is 65, 100 million years old. Yeah, yeah, sure. So one in that whitish area and one in this area down in here.
This is just as a visual for reference, it's no afterwards you can process things that one is also see the events you did for the end. You come up with so just as you have this list, you can see everything that people have answered, like the values and stuff.
It is our first.
What core is that?
Because we have many annotations.
Yeah. Yeah, no, well,
Number one?
The more you take, the better for like science. So, like, afterwards at home. Oh wow, you put it into Spanish.
Yeah, I just tried to.
So the cores are
No, but
numbered.
Yep.
It's in your page, maybe.
Oh, maybe it is actually.
It's core one. And that's in gonna be in the orangish with white and orange. One core in white, one core in orange. So you get whichever one you need to get first.
Right here below me looks like. I'll show you how to do the
Okay.
sample thing then. Know what core number this is?
Yep.
Is it 1 or is it numbers 1 as well? Yeah. Okay.
This area right here is good?
Perfect. Yep.
Submit that. And then go to science. Take sample. And now type sediment here.
I got this one logged.
Oh, have you?
Yep.
Oh, you're doing it. You,
Yep.
That's good. There's someone to be. You don't have to do it then. You don't
Right.
have to do it. Just go, you can go back to the tanks today. And then the boss. Let the
No,
boss-
I just was. Oh, did it? Okay. I think it did it. Let's look.
You've already done it, have you?
Yeah. Okay, there.
And then we can produce you a whole list of like the different samples. The good thing now is it takes some pictures of the actual core.
Yep.
You probably just do it on this actually. I'll probably just do it with this. I'm sorry. Maybe if you.
Oh shoot, that's too full.
It's just at the top, yeah.
Yeah, we need to leave about an inch of water. Sorry, future reference. 'Cause they will
Okay,
dig out
as you
and
can see
blow
at the
up
moment,
on
we've
the
just taken a sediment core. This is sediment core number 1. We've taken a sample at 2,013 meters. The depth on your screen currently has a slight offset showing 2,034.
Yeah, it's a little. It's
Big
right
hello
to the
to
top.
Jamie, who's just joined the feed. We've got someone saying on here that this is an incredible amount of bacterial mat. Yep, it definitely is. Some of the areas that we've been exploring in the Gulf of California, we've seen phenomenal amounts of bacterial mat
Yep,
on the
so-
seabed. This what makes it really a mecca for our scientists to come and actually conduct this science. This is just one of the vents in the area, or one of the active areas that we've seen.
Thanks for joining us. Watch us on
We're
YouTube.
actually then going to
You can
move
DVR
tomorrow
us
to a
and watch
site
it
we
later.
actually discovered by chance
mom and dad will
on the
know
way
now.
here. The plume from that was the strongest plume we've seen in this area, and it looks to be a phenomenal site, possibly even a new vent field. So tomorrow we'll relocate the ship, only about 2 kilometers away from our current position, so 1 a bit nautical miles, and then we'll explore what is probably a new vent field. Now, if any of you at home have any questions, either myself or Mandy Professor Joy will try and answer them. Feel free to put them on our YouTube or Facebook feed. Next, we're going for core number 2. The arms that you see being controlled by the co-pilot
I
who
got it all
sat next
set
to me.
up. We just need to.
As you can imagine, it's quite interesting to control a mechanical arm that is 2 kilometers below us,
This one is.
but the messages to and from that arm are traveling through
brown,
almost several
orange.
kilometers of steel armored
in the
umbilical.
orange. We got the white before.
To control these arms,
I
the
would
co-pilot
say-
is using a
Yeah.
controller known as a master. It is a replica of the arm that's on the vehicle, which is the slave. And as the co-pilot moves the arm, each part of it, the arm subsea on the vehicle mimics that movement. The co-pilot can also open the jaws on there or rotate the wrist. A skilled ROV technician pilot can pick up a raw egg with these manipulators.
Yeah, it's looking good. And if it starts to compress,
We're about to put the core sample into the seabed.
it'll usually, they're pretty elastic and they'll pop back out.
Yeah, I saw compressed.
SuBastian is today carrying 18 core samples, I believe, core tubes to collect samples,
Give it a second, let it.
and we'll probably fill these throughout the dive. As you can see, the sediment is quite soft here. Temperature measurements earlier showed that within the sediment it can get up to about 25 degrees, so a nice comfortable temperature. One of the reasons we see all the bacteria here.
So, oh, that's beautiful.
Principal
Black
scientist
and
has just
sulfate
told
it.
us that that is a beautiful core.
This is almost assuredly a very stinky core.
And we just the debate going on at the moment
Very
is how
interesting.
bad
Little
this is going to
jellyfish
smell
just
when it
passed
gets
by.
recovered to Falco
That's
later today.
beautiful.
A big hello to Andre, saying hello from Montenegro.
Awesome.
Co-pilot will just tap the core now. The tube will then sit on a bung, which is in the bottom of the core holder, and then they'll put one of the black loops over the top of it just to keep it in place. Now, one of the things that does happen on some of these sites is that the core samples may have gas in them, and as we come up, that gas can expand and those tubes can pop off, and we don't want to lose these samples. So those black loops you see being put over the top with tube, there to secure. And as we're doing this, there's a holothurian bouncing across our basket. That's
Wow.
pretty cool.
Look at that.
The brown stuff you see inside is its intestines. It's its poo.
Yeah. It's a nice one.
So ROV
So
operations
I
for
think
this
we're in good shape here. Yeah, go check out the Osmos and then head to the city of Basin, which is where we're going to take
we're
the
about to
majority
lift
of
off
our
the seabed.
tours.
And there we go. We've dropped waypoints so we know where our experiment is, and we're off to look at some other experiments now, I think. Osmos, which I'll let Professor Joy explain about shortly.
Yeah, so we're gonna next transit towards an area just to the northeast of us, where we have Osmo samplers deployed. These Osmo samplers are essentially osmotic pumps that have a reservoir of saturated brine in a chamber, again across an osmotic membrane, which creates a pumping potential, and we can collect pore fluid from the sediments using this potential. And it pumps really slowly over the course of about 5 days. It'll pull in maybe 4 or 5 mils of water, and over the course of a 3.5 month deployment, however, that turns out to be quite a bit of water, and we can get a time series of methane concentration in the pore fluids. And if you look in the video right now, you'll see a lot of little black blobs or dark colored blobs in the screen. That's oil that's coming out of the sediment as the vehicle comes off the seafloor. There's a lot of oil in these sediments. They're quite saturated with oil in many cases. Lots of starfish on the seabed. A lot of flow features as well. It's a very active area of seepage all around here. I don't know what those are. Getting any kind of hits.
How big is this thing?
It's 2 milk crates, but the reflector is maybe 2 feet across. We're getting close. Should be right past these rocks. These are all oil chimneys, Jason.
Oh, okay.
Some are, they're saturated rocks. Not necessarily active right now, but we should be all over it. Nothing in the radar reflector. My horror is that it gets buried, that it got buried. But You always get very nervous when you deploy expensive instruments on the seaboard. Yeah. We are searching for an instrument that was deployed back in November. It's around a big field of microbial mats. So if you see color, see any mats. Yeah.
That's what the thing looks like at the moment. You click on the SuBastian one. It's doing it on the internet. It's all flashy, so it's really slow on the ship. It's off it. And there. It's good, eh?
Okay. I see something on the. We're getting into the vicinity now. There's a spire just off the screen over here that might actually be the edge of the field. Ooh, wait a minute. Okay, there. No, that's not it either. Those are not active.
There's a sonar keyboard there. Labeled sonar.
Oh, there's a crab for Elva.
So at the moment, we're just looking around,
Oh, there's a lot.
looking for one of the experiments Professor
There's a lot of animals down
Joy's
here.
team put down here previously.
Okay.
Our depth is currently 2009. Unfortunately, it's showing 2030 on yours.
There's a nice
This is a
spider
slight
crab.
offset in our live feed.
Blinded by our lights, probably.
Just quickly having a look at the crab that's on the rock in front of us.
There's a shrimp over there too. Should I check the position?
What I'm going to do is try to shoot more waypoints to be offset a little bit.
Yeah.
Different positions that like all the clothes.
Yeah.
So what we're going to do, I'll go forward about 5 meters,
Yeah.
10 meters, right to the head,
Yeah.
and see if it's offset on my page.
At the moment, so you're joining us. This live feed is from research vessel Falco, operated by Schmidt Ocean Institute, currently conducting science
this
in
is
the
all,
Gulf of California.
Quite different.
ROV SuBastian is currently at 2,011 meters. We're exploring a hydrothermal vent sign. I'll now hand you over to Professor Joy.
So there is a lot of hard bottom here. It looks to be potentially some iron, carbonate potentially, with a lot of iron oxide crust. Oh, that's promising. Okay. Oh, God, look at the trash. And that's fishing line. Be careful.
Is that all fishing line?
It looks like fishing line to me. Don't you think? Wow. It looks like all just a.
One of the things we'd like to do if that happens is take pictures.
Yeah, I was doing that, and I was gonna. Isn't there a trash logging?
Yeah, I've logged this as a potential human impact. That's definitely black bags, rubbish.
Wow, somebody just dumped it. Good God. That's so distressing.
Let's get some good footage for that.
Yeah. I don't know. We did see some coral, but that doesn't.
There's a lot of shrimp in that.
Yeah, that doesn't look like.
Where's Elva? Or where's Monica?
At the moment, we're
Get ahead of-
debating. We can definitely see rubbish in there, but we think this might be biological. Could we, if you get a chance, actually, it's good to identify some of the rubbish and see where it came from. Yeah.
It's definitely a bunch of rubbish mixed in with whatever this is. Yeah. Carna, protein, soy protein, tofu maybe? Tofu box. Yeah. There's a lot of trash.
Yeah.
It's been there a while too. What is that, I wonder?
So one of the problems, we're spending some time just documenting what we're seeing here. A lot of the time, out of sight, out of mind, under the
We don't
under
know.
the sea.
That's a anemone. Yeah.
So we're just documenting some of this junk that we're seeing here at the moment.
We saw some things like this, much smaller scale, at some of the chimneys in this area, and we were thinking that it possibly was some sort of coral, but this is too, I can't imagine. But it has, if you zoom in on it again, you can see. See that? I don't know. I mean, it looks just. What are the?
It's like a worm, huh?
Yeah.
See a little pink thing to the
Oh
hanging out at the ends here.
Pogonopterans, maybe?
Looking good. Bunch of them have. Like that worm colony or something?
Maybe. Or maybe a live worm colony. I mean, this one is. We might collect some of these.
Good morning. How are you doing? Good morning. Good morning. Guaymas.
If she wants. Gringo. Okay. Oh, beauty. I think. How tall are these things?
About a meter.
Meter or so?
Meter and a half, meter.
I would really like to know what this is because we've seen these something like this before, and when we saw it before, it was also covered in shrimp.
It was covered in trash too?
Shrimp.
Oh, shrimp.
Or shrimp all over it.
Shrimps.
And interestingly, the one we saw before was growing beside a bunch of plastic fertilizer bags that were degrading on the seafloor.
You know, we saw that in San Diego. Like
It's
a lot
in-
of
We saw that
stuff
here.
growing. Yeah.
So,
Oh, second lake.
Where's this big one? Yeah, we did see it. Yeah.
Yeah, let's go then. We've got it documented and recorded. And take another picture. Do we have what looks like a return on that, or no? Maybe.
I thought I did, but that might have been this. Well, what I saw was off to the right. To the right? See those two spots right here?
So we're gonna keep surveying until we find this instrument. We are pretty near that area where we saw the plastic bags. That's interesting. That's more trash. Jeez Louise. Yeah, somebody just dumped a load. Those are definitely,
Yes, I have an updated waypoint.
it's definitely biological. If we see more of those, we're gonna grab some because I want to know what they are.
Okay.
I don't know what they are, but we're gonna grab some. Let's look at more. And there should be pretty nice orange and white mat target. Oh yeah.
We just got a temperature anomaly here, but now it's like 0.05.
Okay, now we're looking more like it. So we're going on and moving into an area of mats, some sea stars. The instrument was deployed in an area of white and yellow mat in between a large field of spires.
It's pretty flat out this way.
Yeah.
There's something off to the right. Could be Spire.
Should be floating above the bottom, the marker.
Okay.
It's on about a 2.5, 3 foot tether. There are spires around it, and that actually that looks like the 2 boxes.
Yeah.
Yeah, that's got to be it. That's milk crates.
Those are pretty big, though. This is a 30 meter window.
Oh, that's huge.
Yeah. That one good.
Yeah, that's got to be it.
There.
Yay! Hooray! Is the milk crate overgrown? There's the little towers. These are beautiful
Some little chimneys.
chimneys generated primarily from biological biomass. These mats are Vegeatoa, as we've talked about already. This is an area, again, of really active seepage. There's a quiver. There's an Alvin quiver.
It's active.
Yeah. Oh, wow. Yeah, you can see the fluid discharging from this, actually from 2 of these. Yeah. Let's take some shots of that.
Yeah. Get some cool footage.
Yeah, let's get some footage of this. This is beautiful. It's even generating some turbidity in the water. Look at that. Oh, nice. Let's just hover here for a second and get some video. This is quite nice.
Well, we reminded each other.
Looks like a magician's wand. Just, yeah. Yeah, these features tend to have multiple discharge points. So here we've got at least 5 that I'm counting. Do you guys see more? There's 1, 2, 3, 4, 5 over there. 6. There's one at the bottom too.
Is that a hagfish in the background?
It is, I believe.
They look like a snake.
This is pretty spectacular. Yeah, that's totally a hagfish back there.
I don't think it is.
Back on this side.
Yeah, the snake.
Yeah.
The snake eel?
Yeah, this guy is not a snake eel. That's a chimera. That guy's a maybe. It's hard to say. So look at this
Oh,
one.
impressive, that is.
There's numerous discharge points.
Quite a few of them, right?
Yeah.
There's some on the backside.
Yeah. Oh, there's something getting cooked right there. Flowing through the, barbecued vent worm. I don't know, it just got dislodged and floated through the chimney. Yeah, let's see how hot that is.
Great show.
Yeah,
Doing highlights, Tom.
this is a total highlight. Yeah, this is a good one.
We're drilling 2.64 right now. It's all like you can call it.
A little bit to starboard, maybe. Yeah, you're almost over it. Perfect. This is the beauty of an ROV. Just sit right on top of it. Don't have to worry about your windows melting. So now we're lowering the temperature probe into the discharging fluid right above the chimney. We're not quite in it yet, but we're getting in it now. What we'll see is an elevation above the seawater background, which is about 2 degrees.
There, went up a little bit.
Yeah.
5 degrees.
Oh yeah.
So you actually, or you just pilot the vehicle.
He's just reclining right now.
Okay, I'll just-
You want to sit down? Yep, you can, your signs camera down a little bit.
Yep. Yeah, the core is right in front of it. Maybe
Last
move.
week, in the last 2 minutes, it's 9.8.
It's not quite in it now. It's almost going in it. Looks like it. What's it reading now? There it should be in it. Or no, it's above it. It's not in it. You getting anything now? Because it went in and out. Yeah. Yeah. Almost. You could, some of those little chimneys tend to be super hot, or the big ones are, you have seawater entrainment, so they're cooler, but the ones that are closer to the sediment surface seem to be much, much hotter. There's one to the port a little bit down.
You want me to guide it into it? You don't want it down, so I don't.
Yeah.
I can just grab it.
Well, we're gonna do something small.
Yeah. Or the one on the, there's one right on the sediment over on the other, onto the, to the port a little bit more. See that little one right here? This guy. Oh, boom!
Is it just carbonated?
Yeah, it's very friable. This is actually good acclimatization for collecting the oil chimneys. which we'll come over. We'll do that on Friday. This is that the one you just knocked off right there? Because that might be a good one to just poke in. Oh yeah. Oh, now it's blowing.
32.
Yeah, that's 50, 62, 65, 70.
What is the?
80 degrees now.
I'm getting anxious. So let's look at this. See if we can get on parallel.
It's hot.
I'd say I only have 66. You go parallel, it's going to show 86. It's going to show 77. So you got 3 different readings there.
So it's about 80 something ish.
89 at the moment.
Okay.
Keep it up. Well, I did that because we were searching for something. Yeah,
Yeah, right there. A little bit up, a little bit further up. Perfect. That should be raging. That's right in the orifice. Should be over 100, I would think. Oh, it's a little bit out of it now. Right there, right there. Yep. That should be in it. Yeah, 160. That's cooking.
I love that.
Yeah. Let's check that. Let's check this one right here while we're here.
Which one?
This guy, the big guy to the.
Is that right?
Yeah.
This is the last 10 seconds, this is the last 30, it's actually the last 2. And then all you do is click on the highest value and then just all clips to the left. You're charging. No, that's just for the last minute. So you can walk and I can keep it out. You can do all that. Eventually I'm going to do it for like other things, so I'm going to do that now.
Gorgeous.
Scribble is a good one. Scribble event logo.
So that's a. So is that one? That's in the middle of the stream, is it not? It's about 50.
And it is the moment. It is also uploaded to the website as well. Just check it out.
Pretty impressive. An orifice here.
Could you tilt the camera up a fraction just to get the top of the sampler? It's great.
Oh, that's fantastic. The flow around the.
The moment Once they get the map, but that's the way.
Yeah.
The dial.
We're out of it a little bit.
Get it right there.
It's right on the edge. Yep.
79. We went up 85.
Yeah, it's out of it.
Yep. Try to get back to it. I need to get shade.
There we go. It's not quite in yet. There we go. Perfect. Oh yeah, that's it. Gift of the day. That's at 160. Ha!
Pretty warm.
Yeah. 160. Now it's back in it again. No, it's not so hot right there. Ooh. Yeah, that's a pretty good one. But I mean, this whole structure is probably alive because it's the structure. Closer you get to it, it's like 80, 70 degrees. So it's pretty amazing.
Yeah.
All right, I think we're good. We are going. Yeah, let's look for those boxes. Oh, that's a pretty spectacular mount right there. We might.
So they're in between these two spires?
I think, yeah, should be.
Is this facilities?
No, this is Ace's Spire. We're not quite to Ace's Spire yet. The Alvin nav is a little bit off, but look at that. I mean, it's given turbidity in the water. That's unusual for these guys. So the boxes should be still getting a return. I think they're over to the starboard. Well, that nav is off, isn't it? Hopefully it's a consistent offset. Yeah, right in front of us. Vegetoa snow.
Is that going to make a lot of organisms happy? Spreading some
Probably,
joy around?
yeah, yeah. A little bit of food for everybody.
Deep sea smoothie.
Mm-hmm. Action packer. So, where are these boxes? Okay, this is a very nice mat, but it is not, I swear, that looks, these are like reverse fried eggs. Supposed to be orange in the middle and white on the outside. That's what they were for the longest time, and now they're white on the middle with yellow orange on the outside. I don't.
So is that the greeny?
The greeny stuff is the orange Vegetoa, yellow Vegetoa. Actually, if it's yellow, it's more like the white. It just has elemental sulfur precipitating. The orange is bright, bright, bright orange. Okay, that looks familiar. That spire right there. That's Ace's Spire. Okay. All right. That is a very impressive oil chimney. So there, right there. That's it. Hallelujah. I think that's it. Oh, maybe that's not it. No, that's not it. That looked like a box. Oh, maybe it's in that big field over there. See anything on a sonar?
Oh, no, I changed that.
I thought I had seen it too. Okay, this is a big map field.
So bright and yellow.
It's amazing, right? We're quite off that position at this point. These are nice mats, though.
You said they're sitting off the ground a little bit, right?
No, they're on the seafloor. The tether with the reflector is about a meter up.
So are these sample boxes?
They're milk crates with the Osmo pumps inside them. And they have a plastic reflector on top. So here's some more sediment, carbonate outcrop. Potentially, that looks more like carbonate than iron sulfur. Still a lot of active seepage there. Everywhere you see mats, it's a bullseye for active seepage because they have to have energy to survive and they go away if there's no energy source. I'm really surprised we're not seeing them because they're pretty close together. Oh,
So they're by 2 spires.
they're near 2 spires. They're not. There's a pool in the front. Yeah. The spires that they're near are maybe 2 meters tall. Wow. Holy cow. See that? See how bright orange that one is? Are you getting the high def feed? No, you're on the other one. But I mean, this is almost classic fried egg with the orange in the middle and the white on the outside. Okay, so this possibly is the opposite side. I don't know. I don't see anything that should.
To the east or to the west of the
Yeah. Once we figure out like what the offset is, it'll be easy to navigate. But until then, we're gonna have to wander a bit. What about back there? There's spires back there, but no mats really. I don't know. That looks a little different. Yeah, maybe. Yeah, that is the one we were just at. Okay, there's a big spire.
Yeah, it looks like there's something past it.
Yeah, it should be past it. That's not Ace's Spire. That's not it. The spires have, there's 2 really large ones and a bunch of small ones. So we are not there yet.
Yeah, they just away from the front.
Okay. Mat. a bunch of clams in this sediment.
Look at that.
There's a bunch of, see there's tracks.
Yeah.
There's a Calyptogena, chemosynthetic clams. If you look at the track, you'll see the clam sort of sitting upright with its foot buried. I'll show you when I see one.
So we have no one passing. How far away are you?
And we're here.
Yeah, that's all I can see. Oh, you did? Oh, I thought you started this.
This is really dropping.
How far north did you go?
I didn't go that far. You get further north?
Yeah, let's try a little to the north.
You want me to get back to that map?
Yeah, or maybe where the osmo sampler fix is.
Yeah, I think only about 5 meters.
Yeah. Yeah, head up that line and see what we get on the sonar. We're still looking for this instrument. It's sometimes it's quite difficult to find instruments that were left on the seabed because of a slight offset in navigation. Leads to literally going in circles trying to locate the gear. There is near this site 2 or 3 big areas of plastic, just, those canvas plastic bags, like fertilizer bags, big 50-pound bags. They're sticking out of the sediment. They're pretty easy to spot. Yeah. Okay. Yeah, those are not the chimneys. Oh, those are big chimneys. Those big rocks. Come on. This is nothing. Okay, so let's go to the north, see what we get. Hello, Mr. Crab. This is more crabs on this dive than we saw on the previous dive, the previous like 10. Lots of eels too. Nothing up there, huh?
Yeah.
Big anemone. Something straight ahead. We're wandering into the abyss here, looking for our instrument that we deployed back in November. Maybe. Yeah. Oh yeah. Oh, okay. Yeah. That's Alvin. Alvin was here. All right. There's that mound of stuff. And we're here. Yeah. Shit. We found our own landing site. Shucks.
Whoever looked at those people, yeah, that's national companies that are working on the boat to this.
Yeah, this is looking pretty flat and uneventful. I mean, there are clam tracks. Yeah, there's some. That might. Oh, those. Oh, actually, let's take a look at that. This might be that line of chimneys. Okay, those are oil chimneys. And actually, that might be. Yeah, let's check that out. No hits on it though. This actually looks reasonably like the field we deploy these things at, but I don't see anything that looks like the boxes. Nope.
I don't think it's flat.
I'm gonna go recheck the position. I might just bring my computer down here. Oh, God, this is totally not. Look at the little octopus right there. See that octopus? Is that? Yeah, let's get some high def of that octopus. Another rifty, and I'll go check the position again.
How's your
The strangest experience of this octopus's life.
Sorry. I'll get it by the end of the day, or by the end of the cruise.
Yeah, we're gonna head to that.
I really like this. This is like, yeah. Whoa, look at that.
There it is.
Alvin. Yay! Oh no, that's marker 24. Marker 24 is not where we're supposed to be.
You know where that is?
I do. Hold on a second. I have a map. Oh my god. That's pretty. Those are called, those are like beating heart, Halathurian. That's another gift of the day. Gift of the day. Do-do-do. Okay.
The line of chimneys there. Definitely a line of chimneys. What's that out in the distance?
How?
Is that your pump right there? Is that your pump on there? Yeah.
Where?
Right there.
Yes.
So it is, we do have 20 meter also.
Marker 24 is supposed to be over here. Did we move it? We may have moved it.
Pretty close to where it is.
We didn't have any markers, so we may have had to move. What did I do with that drive? Hallelujah. Okay.
Yeah, it's exactly 20 meter outside.
20 meters?
Yeah,
Well,
to the southeast.
okay, sweet. Well, now we know.
I'm gonna drop down and take a look at this.
Yeah, let's fly over and get some nice high def video documentation. Check out everything, see how it looks. Now it was plopped down on a mat. Looks like the mat is. Where's the other box? You see another box?
For, what's the, I was gonna say, for
It measures, it pulls the sample in for dissolved gases. So it measures methane and CO2. We get a time series of methane and CO2.
There should be two of them.
I think there's only one. 2 samplers in. Yeah. Actually,
got some shimmering over there.
yeah. Is Andy asleep or is he awake? Okay. Can you hand me that laptop again, please? Just throw that drive to the side. And make sure that we. Oh, it looks pretty good. I'm astonished. But the mat, it's interesting. Oh, look at the shimmering right there. God, that's really close. I hope it's not melted. Yeah, I have it in my dive notes. We moved marker 24. Wow. It is amazing the amount of incrustation.
Are we picking this up today, or do you put a marker on it?
Well, let's drop a target. We're going to pick it up probably at the end of the day. We need to pick it up today at the end of the dive. That's all encrusting whatever those worms are that we were looking at a few minutes ago. They're encrusting the tubing. It's impressive. Yeah, we'll get them with this. Come on, you stupid thing. That's pretty amazing.
How do you make sure no one comes and steals your experiment?
You put them on the bottom of the ocean so that they need a submarine to get to
Can you put your name on it? It's
Then
against
you-
the
then
first
you-
line of defense.
yeah.
But, you know,
You put
then you put your name all over it.
all over it.
Yeah.
Just in case.
I heard the society's gone to hell in a handcart.
Yeah,
So
yeah.
someone could come in.
We gotta look, watch out for the lucid crabs and
Yeah.
pink hagfish. Pink fish and stuff.
It's pretty amazing how encrusted it is, though. I did not anticipate that.
So was it put in the maps?
Yeah, it was on Matt.
So the map. is
Yeah.
going.
One set of probe vents in the orange, one set of probe tips at the edge of white mat.
One has more growth on it.
And there's 2 boxes. There's another box right around here somewhere.
Oh, so there is a second.
Yeah.
one. Okay.
Oh, look for it.
That should be box number 4, I think.
Maybe over there.
They should be pretty close. They're on it was a big circular mat. And
When you put these down, November?
yeah, it's amazing how much has grown on them, right?
Look like they've been down there.
I know,
Yeah.
I know.
Tell
I-
the story.
The orange Osmo probe has red writing on the handle.
Yes, I have a.
We have to be careful when we pull these out that we know which probe was where, because everything's different now from when they were deployed, so we're not going to be able to tell just by the labels on here.
You have the dive log or?
That's what I'm looking at right now.
No, for this dive.
Yeah. Yeah.
There's more of that stuff. Yeah,
Yeah, so we're totally in the right place, because I said this was right by where the Osmos were. There was this big, and every time we dove here, we're like, what is that? What is that big? Oh, you can see the plastic debris. Any sign of it? It's seriously, I'm pretty sure that we could see them in the same field of view.
I'm going to come at it at a different angle.
Okay. This is the first one we deployed. There's hot water, shimmering water right beside it. So that's the first one. See that trash right there? That plastic bag? That's human debris. So I think it's up to the port. This is so different. This was all a big giant field of mat last time behind that chimney. Yeah, it's amazing how fast it's changed. That's a paper, actually.
What did you call that first box that we saw?
That was the,
Sample 4?
yeah, 324 box.
Or the first?
4 is fine.
There's something right there.
Or
There
the
it
same
is.
one?
That's the same one. 473. So, hard ground.
Other stuff working.
Okay, so bottom water.
I think it's for the port, you said?
I think,
That looks like that.
so that's the edge, and I think the other one is down to the right. Yeah, to the starboard. Maybe just come up and loop around. This thing cannot float away. I mean, it's anchored. Wonder what temperature a milk crate melts at. It could melt, I suppose. This is crazy. We did reposition to deploy the second one, but we didn't go very far. Is that a marker right there? Nope. We have the general area. Did Andy, what was he prepping last night? Just the pumps themselves, not the valves? Did he have any valves up here? How many valves did he have? A 12-quart valve.
Yeah.
But how many of them did he have? One or two?
I think 2.
Okay. Okay, let's go to if we're not seeing it, we're not going to find it. I mean, it has to be around here somewhere close. Yeah, I think we should head to Aceto Balsamico, given that it's, you know, factor that offset in, and that's going to be a bit of a haul. Yeah, to get those cores collected.
Sure. You want to go the quickest route there?
Quickest route, yeah.
Follow the boat, right?
Would you like to stay on bottom and look at bottom while we go?
Yeah, let's stay above, unless it's faster to go a little bit higher and cruise.
What I'll do is I'll come down to a point where we can cruise, but still keep eyes on bottom.
Right. Bridge, ROV.
ROV bridge.
Yes, we're gonna begin a transit down to the southwest. I have a new waypoint for you. You get there before we update it. If you don't stop, we'll update it again.
Okay, cool. Thanks.
Okay, I want to see.
It's another marker here.
Yep. Just fine. Yeah, it's it. It looks like a milk crate.
I think I found the other one.
Okay.
I'll put the-
Holy shit.
That's not it.
Is that it?
Is that it?
Maybe.
You want to know how to stay milk?
Damn. Oops.
You're okay.
6 valves. So Andy has 2 valves. Then there's 4 out there. And
The backup again. Yeah. We've been running with that all. Up facing towards the ship.
so we're going to collect essentially all except 2 cores at Aceto Balsamico. There's only 16 on there. So we'll get 12. And then we'll save 2 for coring near the Osmo sampler. And we'll go back and core more at Aceto Balsamico when we go back to pick up Dan's gizmo.
I had
This is fine. I mean, I'm just logging it, and I'm not gonna, I mean, this will give us a list, so. Wow, that's interesting. That is a heck of a lander, man. That's gonna...
Bridge RV, I've updated your waypoint.
Great, thanks, Chris.
Back.
The box.
Oh, wow. These octopi are...
It's gonna eat that lobster.
Just another bus a little bit ahead of us. Keep it going, Mandy.
Yep. It's fine.
It's gonna be ugly. Probably keep hand up to the right a little bit. Just to, yeah, that guy takes off and it's going backwards. Where? You just have to fix something. Maybe a little bit higher up.
The holes are probably either lobsters or shrimp.
How's it going? Oh, him again. Is he going for him?
He's totally going for it. We're gonna get it.
Look at the eyes on him.
He's laser focused. The shrimp's like, oh my God.
Oh, he's angling for him.
He's got him on both sides.
He's gonna touch them.
Oh, bummer.
I didn't see those yet. No. Oh, look at all those holes.
Yeah.
Gophers.
Oh, is there another little crab, another shrimp down there?
Wow. I swear to God, there's so much down here. We didn't see squat. Yeah, there's a squat lobster and an anemone.
Got it.
That's beautiful.
Worms that can be killed. Log it. That's that one that we were trying to catch. We were trying to catch this last hedge. It's cool. What they call it, the dragon worm?
Yep. We're certainly getting a show today. I mean, that's amazing.
We got one.
Did we?
Yeah. Wait, okay.
Okay. Was there? Anybody want coffee, tea, water? Now it's the time. We got about 10 minutes. You guys want coffee, tea, anything? Okay. I'll be right back. Carmen, can you, if anything happens, record it?
Okay.
Just needs a wait. Cool. So
say this was?
I don't know what that one is. Before it was a Holothurian, and this is a jellyfish. I don't know what that is. That's beautiful. Red belly jelly seems like a good name to me. Gorgeous. Look at that.
Wow.
Beautiful.
I see your license.
Look at that.
Turtle. And octopus.
Look at that. Wow.
It's good.
Yeah. That's something. Yeah. I can tweet it. Oh God, look at that one. That is amazing.
Where are we actually going?
Aceto balsamico.
Whatever we said that hang together. So Alex
You want to sit here for 5 minutes?
I could do that. We're just right there.
Just keep on forward.
Yeah,
I want to walk
I
up top of yours.
Joking.
Oh,
Let's go. I don't know. I just they're all.
we're just going forward.
Just go forward right here. So if you guys have to do something, we're going to change it. We're going to. Right, so they thought I was you last time? No. You do the.
Yeah.
Right. What am I doing? You guys just tell them where's the new way.
Bridge ROV. ROV. Oh yeah, so you know we moved the waypoint for you? Great, thanks. Yep. Wait.
How's the lander coming together? Looks good
It's
here.
yeah. Just putting
Oh,
the
you just swapped. Sorry, I was.
oh, don't worry about it. We're just there for the back.
Yeah, couldn't.
Okay.
Um,
Yeah, we're just gonna simulate the weight with the metal bit and then do the lift.
Pretty stable. Yay.
Yeah.
No need to take it
John?
apart.
I would not take that thing apart.
It's more dangerous to take it
It is,
apart.
yeah,
That's-
it's
that's what I was
really
really
calm
disappointed by
today.
about
We get rough seas.
2 nautical miles.
It's insane.
Yeah, and then parallel lines coming back on either side, and then the survey. Yeah. No, the big silver thing on the platform next to it is the head. And the cable.
Jason,
Yeah, it's about this big. It's next to the.
Oh, it's next to the
No, I just took right when we came back. Yeah.
That's a highlight.
So
Unless they drop
better view without the
Yeah.
porch and the thing in the way.
Look at that.
That's a lot.
I mean,
Oh, nice. That's just another one of those.
yeah. Maybe I just tweeted it. Maybe somebody will tell us what it is. Because I don't know.
Did you call it the red belly jelly?
I will add that to the tweet, and I will tag P. Gergis and ask him if he can identify the red belly jelly.
Isn't that one of those things
No,
from like
we said
Space
hello.
Invaders?
I will.
Yeah. Space Invaders or one of the ghosts
I want to say it was on West Mata that we saw them. It was the first time I'd ever seen them. And the name was highly inappropriate, if I remember correctly. What? The name of those red jellyfish. Wasn't it like slightly inappropriate, or was it the scientists that made it slightly Mexico from?
Hello and thanks for joining us. This is a research vessel Falco. We're beaming a video from ROV SuBastian, which is currently at 2,000 and let's have a look, 35 meters. We're currently transiting, so we're moving fast across the seabed. We are heading to Sito Balsamico.
Laura's very excited.
About,
Laura Lapham,
currently about 200 meters from our waypoint.
Osmo sampler. Yeah, yeah.
Where is it on the camera?
We were really worried we weren't going to be able to find it.
Does it keep focusing on it?
Okay.
At the moment,
The positions
from
are always
our
off
sampling, there's
slightly.
a slight oil
And
gone on one of our cameras, and it's causing us a little bit of.
I would say that about 50% of the
fun
time
as
when
the
I've
camera
deployed
keeps
gear, I'm one
focusing on
cruise
it.
and come back to get it.
Around here,
Found it.
the sediment has quite a bit of oil in.
Unless there's a pinger on it.
So they're just collecting
Yep.
periodic.
So it's got to, no, constant. So we have a time
So
series.
the speed we're going at the moment.
So it basically pulls fluid in constantly, and you can then section,
0.9 meters a
you
second.
know the flow rate. So you can basically say, okay, I'm going to sample every 5 days.
Wow.
And you you cut the tubing up so that it's every X days. It's really slick.
But what prevents the biological activity?
So the current temperature where the SuBastian is about 2.9
It's
degrees
essentially
Celsius.
pulling through a
As we
filter.
transit, we have
So
roughly
it's filtering, it's pulling through a
2,970 pounds,
0.2,
79 pounds
So
per
it's pretty
square
small
inch.
bore. So there shouldn't be a whole lot of contamination
Pressure
in there.
bearing down on us. For those who are watching, so let's locate the two experiments which were placed here by a previous expedition. We've also put the silver frame containing the temperature probes at the start of this expedition, at the start of this dive. We'll recover that experiment before the end of this expedition.
I don't know what, oh, that's the new waypoint with the offset factored in.
At the moment,
Right.
in the control room, we've
The
got
pink
co-pilot
point
Cody,
is the new,
co-pilot
Okay.
J-Rod, and myself monitoring the data. I'm Leighton. Over on the far side, we've got Professor Joy, who's overseeing the science objectives of this dive. Currently on Falco, it's the 11 a.m. The ship is located in the Gulf of California. If any of you have any questions, feel free to ask them on our social media feed on Facebook or also on YouTube.
So we're still transiting.
We have approximately
So ROV SuBastian went in the water at
Okay.
6:30 a.m. this morning. It was just over an hour transit to the seabed. And we've been conducting science, deploying experiments and recovering some experiments that were put down previously. Now we're heading to one of the vents to do some exploratory work. This expedition is roughly 50% ROV operations and 50% ship operations. Last night we were conducting multi-beam mapping of the area where we three-dimensionally mapped the seabed below Falco. During this mapping we detected a plume bigger than any had been seen before. Tonight, once we finish with ROV SuBastian, we're going to go back and quantify that plume, narrow it down, figure out exactly how big it is and hopefully dive this new location tomorrow. At the moment it looks like this may be a new vent field and we're excited to see what's there.
I thought Russ had said that, but I think maybe they're just doing the weight testing. Which is on back.
Hopefully in about 5 to 10 minutes, probably more like 10, we'll be arriving at the new dive location. The next site, sorry, in this dive.
Find the. Stop it.
Well, we're currently about 60 meters away, so it actually might be a bit sooner. Current water temperature is 2.9 degrees Celsius. And ROV SuBastian is exploring a vent field that has had numerous visits before. Was mapped by Sentry, an autonomous underwater vehicle, earlier this year. Well, actually late last year now. Yeah, it would have been November time. During that expedition, the human-occupied vehicles, Alvin completed its 5,000th dive. In comparison, SuBastian is now on its 231st dive in about 2.5 years of operation. Yeah, 150 dives this year, hopefully, fingers crossed. When you think Alvin, the original Alvin, was commissioned in 1964, I believe, so what's that, 36 years plus wow.
Is that number of dives in the current setup, or is it?
No, Alvin's refit was a couple of years back. Not enough days since then to get 5,000 in. So no, I think since its initial commissioning in 1964.
So from my notes, we may have taken one of those boxes back up because the port was
2013
fouled.
it underwent its
So
refit.
that may be it.
What are we looking for at this time?
This site is a huge map field. We want to photo document it, and then we need to collect, I think we have a total of 16 cores. We're going to collect 12 here. This site is, the name of the site is aceto balsamico, and it looks like aceto balsamic sort of vinaigrette. It's a very interesting brownish green color at the surface. Getting some high def shots of the mat would be good.
So we're actually probably about 25 meters away from our next site.
Yes. Yep. A lot of mineral crust too.
No one on YouTube has been able to identify what the jelly was. Oh. No. Now, if anyone out there has any questions, feel free to ask them. Got a whole room full of experts at the moment. Oh, is that an octopus? Yep.
Another one?
That's it.
I can't get over the amount of fauna.
So, what you can't see at the moment is that our ROV pilot has spotted something on our sonar. And in a moment on your screen you should be able to see some of the bacterial mat.
Sort of, yeah. But it's a big field. Are we on top of it yet? Sort of, kind of? Okay.
On the offset.
Is that our target or?
This is a 20-meter offset right now.
Okay. That range circle? Yeah, let's
right where he's at right now.
Yeah, so let's go around that circle and we should see the big field in the middle.
We're just skirting around the edge of our waypoint. These waypoints have come from another vessel. More trash.
Mark number 14.
Mark 14 is in the middle of the aceto balsamico. Yes.
Number
That
14.
more trash. What is that? Okay, that is interesting. Wow. Coca-Cola and
I suspect the reason we see this is because there's like when we were in Nazaré, there's lots of currents coming through,
yeah.
And they just end up getting snagged in there.
So marker 14 is the main mat field. So let's see where. Yeah, on the other side of that. See that mat back there? That's where we want to go.
Who's waypoint? Is this Alvin's or Sentry's?
This is Alvin.
That would make more sense.
So one of the cool things that
Okay, right on. See on the back side there? That's where we want to go. So let's sit down
exactly
facing this way, and then we'll core along that in that yellowish area. Well, first let's get some good video of the whole sort of area.
GPS doesn't actually work underwater to the depths that we're at, so we're using a system called USBL to track SuBastian under the water. Basically, there's a pole that sticks out the bottom of the ship. On the end of that pole is a special type of device called a transceiver, and it shouts
pretty nice
out
mat right
and
there.
says, "Hey, SuBastian, where are you?" SuBastian replies and uses some really complex maths.
Oh, look at the
to figure out
discharge.
the direction
See
and
the fluid
time that it took
discharge?
for that message to come, and then calculate the slant range.
Let's get some really nice
bearing,
high def
and depth of the
while we're
vehicle.
here
We
in a
can
good
then apply
position.
the
You can
latitude
just
and longitude to that location.
hover. Maybe zoom in on that tower right there.
William Jones says George Matsumoto or Steve Haddock and Barry might be able to help us with the jellyfish.
Look at that.
Yeah. We were asked, was Alvin did Alvin leave that marker, the 14?
Did Alvin deploy marker 14?
Yeah,
In 2008.
in 2008. So Alvin deployed the marker we see, number 14, in 2008. I will clap whoever did their USBL calibration. Did a phenomenal job.
This is a very active site.
It's like, what was that?
It's gorgeous.
So, right there. That's the Marco again.
Hagfish, a couple of them.
Are they snake eaters?
Probably. Get a good look at them. This is amazing. Can we hover right here for a second and catch some video?
No, unfortunately it's not. I think we'd all find it cool to see a brine pool.
Wow. It's beautiful. Jason, look at those streamers
So these images are
coming out of that
to you,
on the bottom.
2,032 meters below the Gulf of California.
Those are hypothermal
These
over
images
there.
are being taken by ROV SuBastian, operated off research vessel Falcon, which belongs to
It's
Schmidt
astonishing
Ocean
how you get these
This expedition
pockets
is
of different
exploring
colored map.
and new hydrothermal vents.
Yeah, let's check out the temperature. Are we sitting or are we hovering?
He's pretty stable right there.
Yeah.
So
Oh my God, the sulfur blobs. See these things right here? These are
Scientists
super
is getting
interesting. They're these
excited by
biological
sulfur
stacks
blobs.
of little bacteria. We don't know what they are. We're gonna slurp those. Can we slurp those right there? I don't think they're gonna survive the slurp, but we can try.
So one of the things that might happen at the moment is our co-pilot is getting the controls for one of the manipulators, and we are going to sample some of the bacterial mat and sulfur. What did you call them?
They're little elemental sulfur bacterial blobs that occur around venting chimneys, not in the chimneys, but on the edges of the chimneys. We saw quite a few of these on the last cruise, but we weren't able to successfully collect any. Yeah.
So what our co-pilot's going to do, he's going to take the starboard arm, the arm on the right.
Let's,
He's gonna pick up
what we're gonna do is,
suction
yeah,
sampler.
collect
Now,
these
this
guys,
is basically an underwater vacuum.
and then change
He's gonna
containers,
suck some of
collect
those
some of the yellow,
samples
change containers, collect some of the
to a
orange
multi-chamber device.
in the
Now,
suction.
we can rotate these chambers so we can store different samples in each of the 8 chambers. These will then come up and be studied by the scientists on board research vessel Falcon. To control these arms, the co-pilot is using a replica of the arms below. It's a special type of controller. If he moves apart the arm up here, known as the master, the arm subsea, which is called the slave, mimics that movement. Buttons allow him to open and close the jaws and rotate the wrist. Someone's asking, have we updated the cameras so that we can see the carousel cameras? Not at this moment in time. See if we can get that there so you can see the samples as they're sucked into the chambers. I think.
Alright, so we point at what I'm going to be.
Yeah, so see these little,
Put it on your
yeah, right in here. So the first thing we're gonna get are these white blobs that are right in here.
Okay.
So they start, right, see right there?
Oh, I see them. Yep, I see
Yeah,
them. Okay.
so those, and then we'll switch the canister and collect this, and we'll switch the canister and collect the yellow. And yeah, this starting here, just go down like that. See these? Yeah.
Someone's asking what the yields are.
Yeah.
Are you got it on?
We couldn't collect any intact, you know. Yeah, but look, this is Aquaficales right here, probably. Look at these guys. And this is, that's Aquaficales, it's gotta be. Yeah. I know, they're just mind-boggling. That's crazy.
Matt, do you want to log this as a sample? or
Yep,
log it-
I already,
Oh, okay.
yeah, I logged one already. Oh, yeah, they look to be dissolving. But let's keep trying, because,
You can't adjust that.
no.
Yeah, we can.
You can't adjust
Yep.
that.
You wanna go low, you can?
Yeah.
As you can see, we're sucking up some of the sulfur. This will go into one of the chambers.
What you call it, sulfur what?
Sulfur blobs, the technical name. Blobs.
Very technical term. Is that the port manip or the starboard manip? Okay. And yeah, that's good. Let's switch the canister and move, get some of that orange. There's paralvanellids on that rock too. That's paralvanellids, yeah. And this. So this. Oh, yes, yes. Oh, excellent. Excellent. That's so cool. All right, so let's get the orange mat. Yeah, we're gonna take the temperature after we're done. That was suction chamber 1, right?
Yes. We're in 2 now.
Okay. Biological. Yep.
I'm just gonna flick it off. Try not to shove that rock too much.
Oh, perfect. Keep going down a little bit. See if you can get more of it. Yeah.
You want that piece?
Yeah. Okay. That's good. Look at that. Wow. Okay, now we're going to go up to that yellow. So switch to number 3, and we'll go to the yellow and get that.
Sometimes with these samples of match suction jar,
Yeah.
if there's too much flow going through them, it's going to that's up, which it's not right now. But sometimes it'll get stuck.
Oh, yeah. You'll get a bit of a, yeah.
You'll have to like kind of pick them off.
Yep.
But right now it looks like it's.
I'll show you how to take it apart. It's pretty easy.
Okay. Jacob Gold has asked if the white bacteria feeding off sulfur.
Are you still?
Yes, they are. The white bacterial mat, they all are chemoautotrophic sulfur oxidizers. So they are very good at oxidizing sulfide to elemental sulfur and sulfate. And the yellow color in some of these mats tends to reflect an accumulation of elemental sulfur.
Alright. We're on 3. We're going for the white or the yellow.
The yellowish, yeah. Right up to the port. Yeah. Get all that stuff. And the pink is also interesting. We might collect some of the pink. I don't know that I've ever seen.
The pink on this one?
Yeah, let's get the pink, and we'll get the orange or the yellow next. Oh, it's right on the rock.
Red oil dots. You know, oil red.
Yeah. Wow, look at the oil in the tube. Okay, lovely. Come on. I know you like your home, but perfect.
All right.
That ought to be enough.
Yellow? You want
Yeah.
the yellow, right?
Yep.
You want to keep it in charge 3?
Let's move to 4. Yeah.
Were you thinking about it?
So
That
let's-
that stuff I didn't get. Come easy. Just run that stuff. Not touching anything. The vibrate for it. But I'm not touching anything. We're watching that below the dog with that. Jetty. Got it? Think so?
You're good. 4?
Yeah.
Going for the yellow stuff.
Yeah, let's get as much of this as we can. Oh, yeah. Oh. Let's pull all that off, too. Let's get the stuff up above it and below. Yeah, get all of it. As much as we can. Look at all the oil.
Very, very slow. Try not to get it as smashed up there.
Yeah, there's no shortage of oil in these areas. Let's check the temperature of the fluid, and then we'll move over and start coring.
I'll just re-grab it that handle so I can get the rest of that yellow.
Yep.
Outside.
Oh, yeah. Oh, a rock.
All right, so is that enough yellow? Or you want
Yep, I think we're good.
So, but there's a few questions that I just put on your screen in front of you.
Okay. getting the text. So, oh, you saw it before? Yeah. So I think they absolutely eat the microbial mats. And in terms of the question about it would be cool if these were useful for bioremediation, one of the things that we're examining is natural oil degradation by these communities with the hopes of finding some organisms that have really unique abilities to metabolize petroleum and potentially contribute to bioremediation. So that's something we're going to be looking at with these samples. What are those? Are those snails? Yeah, look at all those gastropods. See those? Yeah. Yep.
Awesome. I'll show you how to do the temperature reading thing. If you go on the top, there's a science tab.
Yeah.
Click that, and then application row. Right? And this, unfortunately, I haven't done it live yet, so if you hit F5, it'll refresh the page, and you'll notice see the temperature going up. It's listed here, the top 10 meters. No, because they might come in and out of the flow. Now then click on the 8. Okay. So if you keep hitting F5 and then it gets to the ultimate value. Okay. No, you can keep hitting it, it's just telling us, taking the temperature.
That's pretty amazing. Yep. All right. Is it going to go over 100, do you think?
I think so.
Yeah. Sweet.
Over 100. You should pick up pictures of scientists using that top so I can put it on
Using the what?
the event.
Yeah.
Yeah, I'm going to make it live eventually instead of after it.
100%.
Wow.
Still climbing.
Is it still going up?
It's going back down.
All right, let's get these cores. So when we go over to the area where we're going to core, we're going to sit down on the outside of that edge where that yellowish mat, looking towards the mat, and we'll take some temperature measurements and then try to core in that yellowy material, I think. We're going to see, should be around 40 degrees.
So SuBastian's temperature probe had a maximum reading of
Is that Riftia?
110 degrees.
That is Riftia.
At that vent site.
Yep.
Okay, one of the things working around this sort of area, the actual seabed, the sediment is really fine. The moment we take off, just clouds the water. You might have seen when we were taking those temperature readings how gelatinous and how fine the sediment was around these locations. When the pilots take off, they give the vehicle a little bit of a shake to try and get some of that dirt off.
Oop, there's another one.
Or we just relocate them
So some map, take some course on this.
find some map.
No, it's a known area.
How far are we from the tower?
Okay, for those watching, the vehicle's just come off the bottom for a moment, and we are going to head to an area where there's some bacterial mat. When we get there, we'll do some coring, take some more samples. The images you're seeing are coming from 2,000 meters below the Gulf of California. The images are being taken by the remotely operated vehicle, SuBastian. The pilots are controlling the vehicle from the control room on research vessel Falco, operated by Schmidt Ocean Institute. SuBastian is connected to the ship via a thick armored umbilical. A 19mm armored tether or umbilical. This tether takes power to the vehicle, several thousand volts, 4,500 volts, as well as video imagery and telemetry data back and forth to the vehicle. We have 5 fibers in the umbilical. One to control the ROV, one for the 4K,
Do you see any mat that's kind of a greenish
for
yellow
all the
color?
other cameras,
Yeah.
one for science in case I want to interface anything, and one spare. What is the camera called with the picture in the picture mounted above the science cam? Oh, that's just us showing one of the other cameras. So at the moment, as we're flying off the bottom, we've got one of the other cameras overlaid so you can see looking down. Does anyone know what type of eels they are? Snake eels. Yeah.
I think so. Yeah.
What do they actually eat?
They'll eat the microbial mats.
They will eat
Yeah,
the
they'll eat the
microbial
mats.
mat. Okay.
Okay, so
And here we are.
on
You can
the
see marker 14, which was left by Alvin, I think
on
almost
the
a decade ago.
starboard
Yep,
down here,
just over a
I think is
decade.
the best.
And you can see all the bacterial mat.
Yeah.
Our
Yeah.
pilot Cody is slowly maneuvering the vehicle, and we're going to land it on the seabed. And then our co-pilot, Javod, will use the manipulators on the vehicle to collect some push cores. And these are small. These are tubes which are inserted into the seabed and then pulled out, trapping sediment inside.
Yeah, and we want to try to
These are
get
stored
the
on the
cores
vehicle and
in
brought
this.
onto the surface where our scientists
And we'll, if
Falco
possible,
will
I'd like
analyze
to.
them.
Well, we're going to check the temperature first. We might end up going up here, depending on what the temperature. Does this look like? No. Let's try this. Yeah, we're going to get 12 of them, but we're going to put them out before we pull them in. We're going to put them all out and then pull them in. That way it's easier to, it doesn't disturb.
So we're just chatting about what we're going to do. We're going to settle down, and I believe we're going to take 12 core samples in this area.
Just trying to find the best spot where
The way
we
we'll
can
do
get
that is
12
put the
good
vehicle
ones.
down and then put each of the cores.
Orange mat is unusual here.
Cover them all.
Usually it looks more like this. We want to find an area that isn't super hot, because the super hot areas tend to not have what we're looking for here. We want about 40 degrees in the sediments, 40 to 60. This might be good right here. Let's give this a shot right here.
Alright, you can see the drawer coming out, SuBastian. This is where we keep all the samples. So in the middle section, where you see all those round circular things, there are push cores that we're going to be using. We have 16 on the vehicle. I think we've done 2 already. And we'll be doing another 12 at this location. The boxes on the left and right, port and starboard side, these are bio boxes into which we can put samples. The arm on the left, which you can see, the manipulator, is currently holding the temperature probe. And the arm on the right, which we were just using, was using the suction sampler to suck up some of that sulfur and samples from the seabed. And there's our arm coming out. I'll switch cameras. Make a better camera. Oh yeah, that one. Transition.
So you want the temperature first, sure?
Temperature first.
Okay, so we're going to go for the temperature probe first, figure out how hot the sediment is here.
The yellow or the white?
The yellow.
So far,
Right at the edge of the
our
yellow and
highest
the orange.
temperature reading is
In an area that, you know, we probably aren't going to
160
core.
degrees Celsius.
To try to retain, maybe right here.
Right where I'm at?
Yep, exactly.
Background temperature here is about 2.9 degrees Celsius.
Okay, so that's, let me do the,
Current reading from the temperature
yeah,
probe in the
let's
seabed
check
is
it,
about
let's
18.7
check a
degrees.
couple more places. Maybe right in here,
You want to go like further up?
like right there,
Okay.
and you could also go over here. Just get 3, so we have a good
Yep,
feel,
Schmidt
and then we'll do
Ocean
one on
Institute
top
is
of
here
it.
in the chat right now.
Right
if
there.
you would like to ask any questions. So.
Yep.
Okay.
So that's at the edge of
Temperature
the.
probe is reading about 21 degrees at this moment. Slowly climbing.
20 again, a little warmer. Yeah. Yep, let's try that other spot, and then the top in the orange might be a little higher up there.
Okay, if I go to that one first?
Yep, absolutely, whatever's easier.
Right in that little brown spot, correct?
Yep, bare spot in the orange map.
Okay, someone's just said on our live feed what they believe the octopus was that we saw earlier.
Octopus or the jelly?
No, the octopus.
Okay.
Says, not sure if my previous comment went through. These may be Vulcan octopus, but the arm lengths and pigment are not right. My current guess is musk octopus.
Showing 23-ish and 22, I think was the highest I saw.
Thank you very much for that information. This is one of the great things about
Good.
having a live feed.
So it's pretty
show, is that
consistent.
anyone can
Let's try
join in
one
and
more.
watch
And,
and help us.
yeah.
We have a diverse range of scientists here, but they don't know everything. So any input you can give is welcome. Thank you, Michael.
Okay. All right, then I think this is a good spot. 24 at 15 centimeters is probably 40 at 25 centimeters. So we want to leave about maybe an inch of water above the top of the cores. And
Okay,
we'll just,
so we've finished with the
essentially
port arm and the
collect,
temperature probe. The
you know,
maximum
along
reading was
this-
about 24
try to
degrees
get along this
at this location.
edge right
How
here.
far apart between the cores?
If we're leaving the barrels in, we can do it an inch. Yeah.
Someone asked if we've ever seen tardigrades, the water bear. Let Professor Joy.
No, they're too small.
They're really small.
Yeah.
But do you ever get them in samples from this?
Never
sort
seen
of-
them in the sample.
Never seen them,
Yeah.
yeah.
It's not to say they're not here, but we've never seen them when we've looked at things microscopically.
Tardigrades? Water bears.
Oops. See. Maybe throw it in a bio box. We're gonna take 12 cores here, so yeah. One of the small bio boxes. We're gonna put Rifty in the big bio box. So.
Alright, should I leave core 4 for something else? Or
Oh, we can take it. It's not gonna blow. I mean, this is not a super gassy.
it's not super gassy?
No.
It's the number 4 or the
Yep.
number 3?
It's number 4. Yep.
I have to start on this side and work my way to the left. How far off to the right can I go? To start?
Anywhere that there's, I would say to like here.
Okay.
We can just sort of hit this line all the way across, and you know, maybe start here where it's a little thicker.
Start there?
Yeah, like right in here.
Right here, right there. The heart of it or on the edge?
Part of it.
Right there, right?
Yep.
Where I'm going down?
Right there.
Right.
Core 4. Yep. Yeah, that's probably good right there. It's hard to say how much it compressed. Is this going to be 3?
Yes.
It is a mesmerizing landscape here, seascape. Yep. Maybe here. Barely any compaction. It's hard to see how close it is, though, isn't it? Yeah, I think so. It's hard to tell. That's perfect. Let's try that. Okay, sediment. Core 5 is next.
You want all 12 here?
All 12 in one spot, or are we going to pick up and move?
We're gonna see how many we can get in this yellow area, and we may have to move, but let's just see as many as we can get. Is this 8 or 5? Looks like an 8, doesn't it? 6, okay. Let's get a picture of that. Yep. Perfect right there. Maybe a little bit more. Yep, that's good. The next one, 5.
So that's my plan.
Park right here. We're going to get as many quarters we can along this green line of that.
Jason, you want to go eat? And then I'll run down there and eat after you eat.
Church there. unlock. Right. So it's no shrink locks, that's turned down, it should probably change everything out. That's right.
Lander floats.
Oh yeah? I bet it floats.
Let's get inside. That was all the weight on it as well.
Yeah. Let's try it right. Right in there. Yeah.
Just to be honest with the bow box.
Yeah.
Yeah.
Going in kind of crooked.
It just sets the camera up a wee touch by it.
Yeah, it's perfect.
A few questions on the YouTube chat there.
So there are a lot of organisms in the sediment in addition to the sulfur oxidizing ones. There's some organisms that live a little deeper down that actually reduce sulfur, so they make some sulfide in addition to hydrothermal sulfide. There are other organisms that consume methane called methanotrophs. They oxidize methane to CO2 and they assimilate some of that carbon into their biomass. And there's other organisms that produce and consume organic acids like acetate and alcohols like methanol. So there's a whole slew of organisms that cycle carbon, sulfur, nitrogen, phosphorus, metals, just about anything you could imagine you find living in these sediments. So the diversity of life is very great because there's so much energy here. You're not limited to specialists. You can have other than having to deal with high temperature, you get a whole variety of organisms that are quite successful in these habitats. Is this number?
I'm going for all the center ones. So
Yep, gotcha.
This should be number 4, but the starboard 4.
Starboard 4?
Right.
Okay.
So all these samples here are going to be your 4, 3, 4, 5, and 6.
So is it 1 through 16 or is it 1 through 8 port and starboard?
Starboard, yeah.
Okay, gotcha.
All
So
the ones we've taken so far are port ones.
yeah.
So,
Tear out before and every.
yep, I'll just put this one in, and then
That's a little muddy, I would say. Let's see it. Is it muddy or is that sediment that's fallen on the surface or is it just,
I think it should
yeah.
be muddy.
I think it's mud that's on the top. Maybe not. Right here, I think. Or right in here, that's all right.
What's that?
So I see the edges, I can see. Okay, 1, 2, 3, 4.
I was trying to get it out further and I was afraid that I was going to break it. So, yeah.
Looking at the bow box, right?
Yeah, you're clear right now.
Yeah.
Right here, right?
Yep. That might not be over the mat. I can't tell how far up you are.
Yeah, have one going over.
Yeah.
Pretty sure that you know what you want.
That's a little.
Right here, right?
Yeah, right up above that blob of mud. Very scientific term. Blob of mud. Okay.
Right there.
Yes, right there.
Trying to just use my elbow.
Yes. That might be, I mean, 5 and those last two might be a little, it's hard to tell. I don't know where the interface is relative to the surface. If they are the slightest bit gassy, they can get blown out the top.
Alright, Chris. I have, right now the temperature probe's in the corner.
Okay.
But pretty sure you can use it to do the rest, go like that way, because that one's the one about. My plan was to just use all the center core tubes. That's way you got some work stone. Number 1, 2, 3 on the port. When I pulled the top off, the bungee broke. It's in one. And the suction sampler, when we're trying to get it in, wasn't working very well with the tube. But dry up. Trying to pull it in. See if you can get it to stay. I couldn't get it to stay. Two of them aren't labeled. So this aren't labeled. I labeled them a line, but that's actually where the sample was found. Alright. There should be 2 markers there on my screen. Up there, I think that's where the 25 off. Yeah. Normally to the south. Okay. Cool. Yep. Excellent. Alright.
So excited for a second there, man.
So we're taking starboard 4 next, is that right?
I don't know yet.
Okay.
Yeah, so this
Okay.
one here, see the one,
The middle one.
middle one there? So that's when we use that one.
Alright.
We want that one.
Or whatever. I mean, we were doing these ones.
That's right.
What do we want to do?
Whichever one's easier to get.
Alright. I'm gonna leave that in the ground and
Yeah.
I can leave that sticking in there underneath the corner.
Yep.
Alright. We'll go for it.
And I don't know whether this is sediment that's come up, but I think this is still pretty well intact right in here. So we should be able to get at least 3 more before we have to move.
There? Oh, yeah. I can move it. From there.
Yeah, put it forward, but there's nothing. It's just got.
That's the cap on that one right there too, right?
Yeah, just gonna double up.
But no, there's already a second cap on it.
So I'm not sure. I think
I can go to the right.
this one. These are the only 2 that have anything in them. I don't know if they're doubled up or not,
I
but
know what it is our caps. Because we've got
yeah.
these-
There's one here. There's one here. I think there's a second one here. There's not one here. There's not a double one there.
My box lines come in there.
it's easier after this one, we could pull them in and put all the caps on, just to clean the basket up a little bit, if you want.
Security caps is there.
Yeah.
Maybe just leave it.
Ah, it's caught. Get up there. Not now. That's fine. It'll work. Yep.
Gonna send another picture. Did you see that?
Yeah. It's amazing.
It really is. It's gorgeous. Let's try right in here. So we're essentially pretty tapped out right in this area. So we have, I don't know, that's pretty thin. I think we're gonna have to move, find another one. So this is, they're both sets. So this is port 1 through 8. Actually, it's just 1 through 8, and then the starboards, if you look in this sample storage thing, yes.
So the white mat up to the left is the last one that's in there?
Like right in here.
Yeah, like
and then you
right
can
in
get
the center
another
of
one
the
right in
mat.
there.
Alright.
I think you can get 2 more in there. So these are like starboard. What number is this? Is this 6?
Yes.
Okay, starboard 6.
They're good?
That's nice.
Yes, very good.
So they have the same numbers, just
Yeah, yeah. I didn't call the other ones port because I didn't realize they were both 1 through 8. So the port is just 1 through 8. So give it about an inch at the top. And if you see it starting to compress slow a little bit, right there, I think.
Happy?
Yep. It's really hard to see when it's. If we get 15 centimeters, 20 centimeters, we're probably good. How do you guys feel about, let's try to do one more if you can, right here. Because 2 in the front, in the port at the front have been used, all the rest are empty.
Okay.
Actually, this one here,
Yeah, far.
So I've already logged all these
All the way right.
as going in, so you don't have to log them when they're coming out.
oh, okay.
I logged them already,
Starboard.
I think. Let me check. Yeah, see, starboard 6. I logged starboard 6 twice because I wasn't sure if I had logged it.
So
I mean, you could log them coming out. It's not going to hurt. That way we'll have the going in time and the coming out time.
The only benefit is they'll put them in the sample report if you do them individually, so you'll have one with samples and it'll put like all temperatures and stuff.
Yeah.
You could just say 12 cores, really.
Yeah.
If you wanted to, if it's all in the same location.
Or if you wanted to assign them individually, you could do that.
Yeah. All right. All right. Wait. So this is starboard number 3, I think.
So, you're viewing ROV SuBastian's video feed
Yeah.
from 2032
I have not put anything on
meters
starboard
below
3.
the
No.
Gulf of
I'm gonna give you the
California.
tape recorder so that I don't
We're currently conducting
haven't been talking a lot.
push
Is
core
it? How do you,
sampling.
mute it?
We're collecting sediment around this bacterial mat. There's just a slight pause in operations as our co-pilot puts on his glasses.
I can see stuff.
Hello, Dewey White from La Jolla, California. Thanks for joining our feed. Scott says hi to Russell. So we'll be taking 12 push cores, I believe, here. So for the next 2 weeks, Avi Falco and ROV SuBastian will be conducting operations around Guaymas and Pescadero in the Gulf of California. We'll be taking samples like this and exploring some of the known van systems. As well as exploring some of the known van systems, we will also be mapping and looking for new van systems. Last night, just before Falco arrived on station, we were conducting 3D mapping operations. During that time, we found a substantial plume. Tonight, once this ROV dive is completed, we'll then head over to that area, continue mapping, and try and get a good feel for how big this plume actually is. Tomorrow, we'll be diving that location. Hopefully, we'll have something totally new for you to see. That location has not yet been explored, so who knows? Hopefully it's an entire new vent field.
How's that?
So I've just swapped the screens a moment so you can see in the large overlay image our basket and the cores in the sediment all lined up. In the smaller picture-in-picture you can see us looking out from our basket. Pilots and co-pilot change views as they're doing the manipulator operations. They've also got a number of cameras that you can't see on this live feed just to help us get some spatial awareness as we take these samples. To control the arms, we have a master unit on board the ship. Now this looks like a miniaturized version of the arm on the vehicle. As the co-pilot moves a section of these to control the jaws, and others to rotate the wrists. Takes a long time to become proficient using these arms.
Alright, so you did, so 4, you got 1, 2, 3, 4, 5, 6. So, 4, now 4 was in that one there.
Alright, so we'll go rows or front row, second row.
See that one
Alright.
there, and then that one there, so this works easy for you.
Okay, so 4, then 3, then 5 before.
Please, yeah.
Alright, you can start.
Hello, David, if you're tuned in. Joining us from the Gulf of California, 2,032 meters below the surface. These images are coming from ROV SuBastian, operated by Schmidt Ocean Institute from research vessel Falco. At the moment, we're just stopped on the seabed while we collect some core samples from around this bacterial mat. These are just tubes which are put in the seabed, and they extract some sediment, and then we put them in the basket and bring them up with SuBastian. Once on board, our scientists extract the cores and study them. Obviously, with the presence of bacteria, all this bacterial mat, there's some cool things to study. At the moment, we're taking 12 cores. ROV SuBastian's rapidly filling up. Our first dive has certainly been eventful. Now, if anyone out there has any questions, especially any about SuBastian, we have our ROV supervisor in here, Russ. Chris is working the manipulators. Carmen's doing some mapping in the back. Ask away. As you can imagine, controlling these manipulators on a vehicle that is 2,000 meters away from us is quite difficult. Not only is it 2,000 meters away from us, but the messages are actually traveling through several kilometers of 19mm armored umbilical. Through this umbilical we power SuBastian, which requires around 4,500 volts, and we also send and receive data and control commands to the vehicle, plus video coming up. SuBastian has a number of cameras. You're seeing some of them. We have a 4K high resolution camera. We also have several HD cameras all over the vehicle. These cameras are used by our scientists as well as the pilots to safely navigate the vehicle. The scientists have a camera on a pan and tilt mount so they can look around as we transit. As well as streaming the data ashore, it's all logged locally in high resolution on board the ship, and each of these dives can produce many terabytes of data. This site was previously visited by the human-occupied vehicle Alvin in 2008. We're here 11 years later, taking more samples, a follow-up to some of the studies done on that expedition. As well as studying this location, Falco and SuBastian will be visiting other locations around the Gulf of California, both here at Guaymas and at Pescadero, two of the event sites. In between ROV operations, we'll be conducting multi-beam surveys of the area, and this is good as not only does it give us a three-dimensional map of the seabed, remember only a small portion of the world's oceans are mapped, it also allows us to find new plumes. Last night during routine mapping operations, Falco identified what is probably one of the largest plumes in this area. Tonight we'll go back and quantify that plume coming up from one of the hydrothermal vents, and then hopefully tomorrow we'll dive that location. That location has never been dived before. Previous expeditions didn't map in that area, so hopefully everything we do and everything we see will be brand new. So stay tuned for that. At the moment we're continuing our sampling. The plastic top and the loop that you see there to secure the cores in. When they go into the seabed, they take the mud, and obviously it's quite a laborious process. The last thing we'd want is one of those cores to fall out. The other thing that happens is if there's gas in there, which sometimes there is the vehicle ascends, that gas expands and those cores can pop off. So those loops which the co-pilot are putting across the cores at the moment are just to keep them in position as the vehicle ascends, and also during recovery when the vehicle's quite close to the surface and being moved by the motion of the waves.
Yeah, I'm not sure what caps are though. Not sure what caps are going. Yeah, I think that one's, I think the one that's sitting right there. There's two and six. Something that one up. Five.
As well as the ROV and the mapping, which form large parts of this expedition. We're also conducting water sampling using Falco's CTD rosette. Now this is a large circular type sensor with 24 bottles on there, each are able to hold 12 litres I believe. These bottles go down open, and at certain depths we can trigger them and they close, trapping the surrounding water or water from that area inside the bottles. These are remotely triggered from the ship, and the sensor also has conductivity, temperature, depth, oxygen, turbidity, fluorescence sensors on there. And we're really using these on this expedition to hunt the plumes coming out of these hydrothermal vents. The water samples will then be processed on board the ship. One of our teams on board is looking to see what viruses are actually present in that water.
Okay. Yeah, this is Jason, and AGD in California is asking about are there any other microscopic organisms that you find in your samples eating the sulfur besides bacteria? And yes, there's archaea, which is another single-celled microorganism that feeds on the sulfides and sulfates in the bacterial mat. They're similar to bacteria in a lot of ways, but they live in these extreme environments. So yes, there's both bacteria and archaea, and oftentimes they live in a symbiotic relationship where one feeds the other the metabolites from their own processes.
Sitting here collecting sediment cores.
Alright, where does this thing go back?
1, 2, 3, and 4. So inboard, forward.
Inward,
Second row.
1, 2, 3, 4, 5. What number is this?
It's one of the starboard ones.
Yeah, it's 4. Okay.
I thought it was number 1.
Yeah.
I thought it was the app one that's got like black panels and everything from the garden.
No, that's 5.
Well, the reason is because I took those other 2 out. I thought they were all apart.
We're using the second row first.
Okay.
That's for number 4. So it's like this.
So, alright. How much sediment depth did you?
I mean here, the last dive here.
Yeah.
Well, you can actually take really deep cores here. It's only 20 degrees at 15 centimeters. Most places it's 40 degrees at 15 centimeters, and 80 at 25 centimeters. So here, 25 centimeters is around 65 maybe. So we'll bring the deep cores on the last dive here and collect deep.
So for the venue collected today, who do you want to plans for that?
I was just gonna metabolomics.
Yeah, it's got a freezer.
Yeah. You can do
Right now, it's
DNA.
going back and trying to
Sequencing.
Yeah.
Yeah.
One.
Okay.
Far right corner. That's where that is. Did you see my wish list on the far right corner?
I haven't seen it. I saw the email come in, but I haven't been reading. Mhm. Yeah. Sweet. Awesome. Yeah.
But he makes up all that stuff. I was thinking it's kind of a shared thing. We're sending the CCRC.
Yeah.
I guess 5.
Yeah. Yeah. That'd be cool.
Three and 5. 5 is right one. 3 is the left one.
So we have 2 weeks left. We fly home 2 weeks from tomorrow, right? The 14th. Tomorrow's the 1st. So we fly on the 14th, which is 2 weeks from tomorrow. So that means we would go to Pescadero. Oh. Week from Saturday. Oh yeah. 6 or 7. Yeah, maybe 8. So it'd be Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. Saturday would be 11. I think we'll get 8 days here maybe. We don't have the permissions yet. I was just checking with Graciela. She said she hasn't heard anything. Yeah, she said it was no big deal, but that it might take a week. So.
I noticed someone asked what are in the canisters. Well, they're push cores. Basically, we're just putting plastic tubes into the seabed and extracting sediment samples. These will be brought up onto the ship and then studied. If you're looking at the screen now, it's a plastic tube with basically sediment, mud in the bottom.
Up a little.
The person asking about the manipulators, guys on board, service the manipulators.
There's a question about shilling robotics, servicing the manips. We are collecting water at the animal sites, and if we get any rocks, and at the Osmo site. We could collect some here, over at that venting orifice, if we wanted. We've got 5 bottles. This number 7. Let's try over here. We have 4 or 5. We have 7 total, so we want to do 4 here. So say, you know, maybe there, over here, you know. Yeah, just avoid that big rock and trying to avoid this. That looks elemental sulfury. Look, this looks more like matte than this does, like right here. Yeah. It's a pretty good angle down there.
If you look, alright, if you look at this one right here,
Yeah. Yeah.
you might be able to see it better.
This one's, yeah, it's not straight. It's not straight yet.
So you might see a better indication of how much is in there.
Can we zoom into this at all?
No,
it is tight.
Yeah. Yeah. It's, if you can pitch it back a little and nose over.
Yeah.
Yeah.
Just I'm losing my distance.
Yeah.
Hello, and thanks for joining. We're currently at 2,032 meters. We're collecting the last of our sediment cores here.
Yeah, I mean, I can just try to get it where I can get it, but I mean, that's pretty much it. I can get it in there, but it'd be at an angle that's...
Yeah, we need it straight up and down. Is the temperature probe still in the sediment? Okay.
I can put one in closer, put this one closer, and then pull that stuff. Right there. The white guy.
Since it was cored on both sides of that, though, you'll have to go in really slow, or else it'll just smush it. Yeah, let it straighten up a little bit more. Can you go out a little bit more? Yeah. Right here. Just straighten up. It should be right over it. Yeah, that. Maybe a little bit over. Sorry. Yeah, try that. Okay, good. Let's go real slow. Keep going, keep going, keep going, keep going, keep going, keep going, keep going. There. It compressed big time. But that's okay. The tube's not full. So we might want to pull it in, because we're going to have to move, right?
Well, just like...
Okay.
Right, is there anybody out there who has any more questions they'd like to ask?
Yeah.
Currently 1 o'clock on the ship. We've got about another 3.5 hours probably at this dive, unless we fill up the basket. Well, on the way to getting all the cores at the moment. Things have slowed down a little bit here while we stop and sample. We haven't been driving around for the last hour. We're collecting sediment samples from around this feature near all this bacterial mat.
good one. See how much that compressed there? Compressed like 2 inches. Yeah. Picture.
Okay, you are joining us 2,032 meters below the Gulf of California. We've now been in the water for roughly 7 hours. Explored some pretty cool features.
Flies by.
Seen some sad human impact, some rubbish that had been dumped on the seabed. And at the moment we're just taking sediment samples. The clear plastic tube that the co-pilot is currently putting on the core sample that's just been collected is to keep them in place. Sometimes when we're recovering the vehicle near the surface, waves can knock these out, or even the gas that sometimes is in cores as we surface can expand and pop these out. So, what you're looking at here is SuBastian's left or port manipulator arm. This is being controlled by Chris, our co-pilot, on board research vessel Falco, 2 kilometers above SuBastian's current position on the seabed. Chris has spent the last hour collecting about 12 core samples. Someone's asking what are the white patches on the seabed. This is bacterial mat. Oh. We taking temperature readings. Just stowing our temperature probe. Okay, thank you for joining us. You're currently seeing images from remotely operated vehicle SuBastian, 2,032 meters down in the Gulf of California. We're currently part of an expedition to look at known hydrothermal vents and discover new hydrothermal vents in the Gulf of California. The images as you're seeing on the screen at the moment are coming from remotely operated SuBastian, 2,000 meters below research vessel Falco, operated by Schmidt Ocean Institute. The water temperature down here is around 3 degrees Celsius. At the moment we're just finishing off some sampling at this location. Some of you will be able to see the blue line, piece of rope sticking up in the middle of the screen. This was deployed by the human-occupied vehicle, Alvin, of Titanic fame. A decade ago, we were revisiting this site and collecting new samples. In a moment, we'll be moving with the vehicle. At this moment in time, we're just stowing some of the equipment, getting ready to move off. I'd like to say big hello to Patrick in Gargunnock in Scotland, tuning in and watching this feed. Hope you're enjoying this. We're not quite octonauts, but we're there. And big hello to our shoreside team, California and Seattle. The arms you're seeing here are incredibly powerful. The co-pilot who sat next to me is controlling them from the vessel, 2,000 meters above SuBastian. They're a replica of the arms on the vehicle, the controller up here.
We're going to try to get in this area right in here.
Co-pilot
Right
moves
in
a
here.
section of that arm. The corresponding section on the vehicle, 2,000 meters below us, moves. Those commands to move the arm are being sent through our steel armored umbilical, and they're traveling about 7 kilometers. We've actually got spare tether on the drum.
We're going to have to boogie after we collect these cores.
At the moment in the control room, we're just discussing the plan, where to move off next.
I saw some up at the Osmo site, dead ones.
21 pounds.
Pardon? Yeah, it's going to take a while. Yeah. Yeah.
I've been asked, what is the robot trying to get? Well, Patrick, at the moment,
5:30.
the robot is just securing some of the equipment that we've just been using to sample. As you can see
mean,
now,
we could-
it's slowly lifting off the
We have
seabed.
12
All
hours
the
on
white
the
stuff
bottom.
you see on the seabed is
Collecting the rift
bacteria.
is going to be
And
an
some of the orange.
hour and a half with the chemistry and everything
This
else.
is small
it takes a long
underwater
time.
hydrothermal vents.
And
Some of them have had hot water coming out, which we measured earlier. The highest temperature that we've seen on this dive so far has been
Not yet.
160 degrees Celsius. So pretty hot.
yeah, you probably won't today because there's only 16 on there. And
I've just been asked,
These
how
are
about
so
a big
hot, there's
hello
no
to
animals.
Paddy Junior Divers, Nico 12, and Demetrius 9 in San Diego. Hello to you guys. Hopefully you get the chance to go in a human occupied vehicle or do something as cool as this. 2,000 meters down. To put that into context, the average diver can go to a maximum of 30 meters. Where we are at the moment, there's no natural sunlight 2,000 meters down. SuBastian carries its own suite of high-powered LEDs that illuminate our work area. Just going to change the video feed. So I've just switched views, so we're looking down
the
at
whole
our
back
basket.
row.
Now the basket contains all our sampling equipment and where we stow some of the samples that we collect during the dive. It's kind of like a drawer, kitchen drawer. You can come in and come out. At the moment, the co-pilot is removing the plastic tube that secures one of the cores in place. We'll take one of the cores out then, and put it into the sediment and get a sample. The boxes you see labeled B1, B2, B3 and B4 stand for bio box. At the moment these are just empty boxes. We can open and close them. They're all hydraulically driven, and we can put samples in there such as rocks and anything we might pick up off the seabed. The co-pilot sat next to me is controlling this manipulator arm from 2,000 meters above SuBastian. Now SuBastian is a remotely operated vehicle. No one's actually inside it. We're all sat in the comfort of the control room here, drinking coffee. And this has many benefits. We can easily swap people out. Just now pilots and co-pilots changed. Can't do that as easily on a manned submersible. The other benefit is we can keep SuBastian down almost indefinitely.
So
The 19
starboard 1
millimeter
and 2
armored
are
umbilical
empty.
that connects
Starboard
research vessel
7
Falco and
starboard 8
SuBastian
is empty.
supplies
Port
SuBastian with
7 and 8 is
4,500
empty.
volts,
That's 5, right?
sends the commands and receives them back and forth to the vehicle.
Starboard 1 and 2 are empty.
That way,
But
as there's
there's
no
5
one in
empty,
it,
there's 7 empty.
we are
right
limited
now.
by human endurance, but luckily we can swap pilots in and out. We also don't have batteries, as I was just saying. We supply all the power down the umbilical, so we don't
just
have
got
to
one.
surface
You
to
only took
recharge
out
our
one.
batteries. And now ROVs can be kept down for days, if not weeks at a time. In some commercial applications, they'll spend months, if not years.
That's 8. I thought it was 6 too, but it's 8. It's on the back row.
Okay, so are we happy with that position?
Yes. Is that straight up and down? It's pretty
Just
close.
this way
Yeah.
around. Let's launch,
So we went quiet there for a moment while our co-pilot actually got a sediment sample. The dust you see all around the vehicle is stirred up as our thrusters keep SuBastian on the seabed. And here you can see that sediment sample is about to be stored in the basket.
I think. Shit.
See, that was a nice sample with a lot of bacteria. Pilot gently nudging the core onto the stopper at the bottom of the quiver. Now they'll put a loop across the top to stop the core popping out as we surface. So we're going to go for another sample now, in a moment.
On the starboard side. Yeah, I'm looking now to see. Because
And we are going for core number 7. SuBastian currently has 16
so
cores on it.
okay. Yeah, so core 2 and core 1.
Who would like to go? Would you like to go to the left of this?
At the moment, the co-pilot is chatting with the principal scientist to figure out exactly
Yeah, and
where
we
we're going
should
to place
probably
this.
leave it in and get them all
Cool.
in there, since we're going to take them close together. Yeah, until we pull them all out.
And there you can see the push core going into the sediment. Co-pilot gently pushing it in. Number 8. How many did we pull out that first set here? 7? So I think.
James, where did you put that hanging scale?
Alright, C-man, left hand side, bottom control. As you walk in.
Okay, we've got the next core, and now we're just debating where we're going to actually put the
It's all
core.
silted up. Let's say here or here. Either one of those is okay. Maybe right
Principal
there.
scientist is pointing to an area near the
Actually,
existing core.
can you reach that right there? 4.
There you can see the push core being pushed into the seabed.
I just think it's bad.
I'm gonna do just try one more. So this is core 4.
I guess like a shape with like some resistance to it. Yeah. To get it without cold.
Do you want me to go and get one? I can get one. I can get one.
Hell. So the problem is that these went in here, and then core 2 is listed again. It must be core 2 on the starboard side.
Definitely have 2 front.
2 in the front or 3 in the front taken? The 2 on the port side.
From here, I can see that one's definitely got one of those jobs. Definitely got something.
No, those 2, 1 and 2 are definitely full on the port side. Carmen, is this number 5 right here?
Yes.
Okay, so that must be core 5 and not core 2.
Two left, they always most definitely. These 2 front. That's my fill. Oh, yeah, you can see the front. That's look, Mandy, she's got it ready.
Okay. So was it 2? So it was 4. It was 4, 3, 4, 6, 5. Okay, that's right. Good for you. So it's 3, 4, 5, 6, and then starboard 3, 5, 4, 6. But that's too many.
Just
The red. So the red.
5, then 4 with the starboard.
Okay. 5, 4.
No, 4 and then 6 and then 3. Sorry.
Those are all starboard.
3,
4, 6, and 3 are all starboard.
So that's the 7, and now we're in the second set, which is starboard 8, port 7, port 8,
yes.
and whatever these ones are right here. Port 7, port 8, and so port.
Starboard 7 and 8 and port 7 and 8 too.
Okay, so which ones are still available other than 1 and 2 on the starboard side?
It's looking like that's what you have available.
Okay, so we're good then. Is number 7 filled on the starboard side? It is, right? Yeah, I need to put this on a piece of paper.
I can
Come on.
help
Yeah,
you with
yeah,
this.
Yeah. So that's 1, 2, 3, 4, 5, 6, 7, and then
8, which is the far left.
and then 3. So that would be how many? So there's 3 out right now that he did. Yeah, but he did 1 before.
Right.
He did 6, 7, 8.
Or
3. So that's 12. We should have 4 empty. Because there's 1, 2, 9, 11, Or so this is 12. And there's 16 core tubes.
But we have all
1, 2, 3, 4, 5, 6, 7, 8. Starboard.
I'm sorry, this is first. All are full now.
They're all full of different.
So we have 1 and no, it's.
One and start.
Start.
But what about starboard 5 and 7?
Sorry, 5 and 7. Five. It's full, and 7 too. Istanbul.
So he
Seven's
comes.
the one they just put back.
But
So
that's
they're-
port. Oh,
No,
okay. On the
1,
starboard.
2,
Okay.
4, 5, 6.
Yeah, we need to have paper logs because I'm
Yeah.
not going to remember those.
Because the template's links and everything.
I've got some too. I just didn't do it.
They have, if we have a lot, we just,
Just for mark the number in any circle.
yeah, I think this log can be useful, but it's part of it. Okay.
I never see that about a ball,
Right.
and I feel like nothing.
Yeah, yeah. No, I think we should have that. Check this. Then just check to see. I wrote first. That's right. So maybe.
Yeah.
That's what it is.
What?
We had 1 and 2 near the
Port.
Osmo
No, that was near Dan's sampler.
or Dan's desk.
Yeah. No, I've got that down.
You
As-
do
yeah.
1 and 2.
Filling this up.
Oh, great. Yes.
That's a nice one.
If you need a pen,
No, this is good.
yes, just
So there was a.
Yes.
Oh, there's the other one.
no. The same are for the sediment, the for the sediment. Just one. Just one, number one.
Oh, what is up with these? Okay, so we have 2 left, right? So that's the last of the acetobalsamic, right?
And we're just stowing the last of the push gauze. then we'll be moving off.
What we typically do on those logs is we write the time in the little, that way we know. Yep, we are.
This is the last of the course, so
Yep. So what we're gonna do next is transit to Rebecca's Roost and collect.
Okay.
Look for mussels on the way, so fly sort of close to the seabed. And
we're just debating what to do next.
I'll be right back. I'm gonna run to the bathroom.
Looks like we're going to start our transit. We're going to move off from this location.
Not that I've announced that to the
Head
entire
to
world.
a place called Rebecca's Roost. At the moment we're just picking up the temperature probe in the port arm. So, we just stowed the basket and we'll be moving off. We've just collected 12 sediment cores in this location. These will be brought up to the ship and studied by the scientists on board. Big hello again to Patrick in Scotland. Right, and now we're about to move off. And we're about to take off the seabed. It's an interesting shell there, isn't it?
Bridge ROV control, I just put a new waypoint is head due north.
The ROV pilots are just chatting with the bridge. And here we go, starting our transit to Rebecca's Roost. Leaving the site where we've just been for the last hour, taking core samples. And as we move off the seabed, we always kick up a little bit of dirt. It's really fine sediment here. Right in front you can see the rope from Alvin, which was left there 11 years ago. And all the bacterial mat, all the white and yellow that we see here.
Yeah, we'll come down, once we get clear, we'll come down and 7 months in bed. You can use that camera.
Okay, and to those watching in Scotland, to Patrick, good night. Have a good sleep. And hopefully you can join us tomorrow for the next ROV video. Tomorrow we'll be diving a location we found last night while we were mapping with the ship. A large plume from a hydrothermal vent. This hopefully will be exciting. Good night and love you. Now we're heading off to Rebecca's Roost. Just transiting along and seeing what we can see en route. The scientists are looking for some mussels to collect and study.
So we are transiting to our next sampling site, and what are we going to be doing here? We're
Collecting
tube worms, Riftia tube worms, and we will also be looking for clams as we cruise along here, mussels, as we cruise along here, and we probably have another 10 to 15 more minutes before we get there.
Yeah, most of it is it's pretty cold there. Not easy to core, so most of this
Tend to
they
move
slide
them
out.
because they're so soft.
Yeah.
I saw it.
They're so hard to
So-
get. This is
Probably
interesting.
it's not so easy now.
I have taller core
If you have-
tubes.
Mm.
That's what we
Very
need.
long.
Yeah,
So you get more.
yeah.
Yeah.
Fill it 2/3 of the way up, you get it half full usually.
Yeah.
Oh, there's another octopus. Look at that guy.
Mm.
Yeah. Let's get him.
2719.
He looks asleep. He's either asleep or talks.
Reading. If he makes.
Oh, his eyes opened. He took a peek. Hello? Hello? Here I am. What is that light shining on me?
Nice.
We had one, did you see the octopus that was trying to get that was pretty good. There's another.
I had nothing else to do. I mean, I did something in between, but I was watching you.
Bacterial map.
Oh, wow. Holy cow, look at this one.
Mm.
Holy cow, Bobby. Sort of stop for a second.
Yep.
Take the turn out the line.
So the spot you were sampling, what was that?
Aceto balsamico,
Oh, that is that with the number 14.
marker 14.
I saw it in the I
Yeah,
took
yeah.
Just because there's
Yeah.
one.
There's one
spot
clump of riftia there, yeah.
I noted
Yeah.
it. I have the pictures also.
Yeah.
But
It's a pretty nice clump of riftia. They're not a lot of them, and they're all about the same size.
They're
So,
large.
yeah,
I think.
yeah.
I mean,
Oh, wow. This is a, look at him eating the mat right there. See that guy? Look at him. He's eating mat. Oh. Tag.
that one also.
Yeah. Wait, see if we can get that.
Oh,
Oh, look at all those crabs.
1942. Yeah. See, this is vesicomyid. This is not a muscle.
No, I haven't seen. This is where, I mean, I'm trying to keep my eyes out for
Yeah,
mussels.
we're
They
looking
should
also.
be here.
I think it's.
Oh. Is that mussel?
No, this is all clams.
Yeah.
Because even.
Oh, yeah.
Mm,
They're fat. Or dead. They're also
if-
dead.
Yeah.
So.
But they tend also, the outer shell tend also not to be white, but
Yeah.
brown, like this one here. See?
Yep.
And from the color, then they look very similar to mussels.
Yep. There's a lot of clams here. I've seen a fair number of live clams. I did see one set of mussel shells early this morning when we were just flying around. Yep. Only maybe 4 or 5, and I'm pretty sure they were mussels because the shape of them were different.
They were open, but that's
Yeah, they were open. They weren't live. Yeah.
But I mean, if they are.
We're going back there to that spot. So we'll see if there's anything live around.
So that one's looking down. This one's looking a bit further forward. I asked John about that.
Otherwise, you would collect the shell at least to see what it is from the shell. Just to, because if they're really mussel shells, then the mussels are also somewhere.
The shells, there should be animals.
Right, somewhere. But you could look closely at the shell then.
Yeah. There's a fault. Right here. Yeah. There's a bunch of rocks. Did you see that other place this morning with the rocks? Yeah.
This must have been very early in
It was very, very early, yeah. About when we were just on the bottom, when we were looking around. These are interesting.
around 8:30, no, 7:30. When have we been on?
It was maybe 8:30, 9 o'clock when we were looking for the osmo samplers. Yep.
Sorry to interrupt. So the plan is we'll do some mapping, we'll put some lines in, like 2 nautical miles long. So along
Yeah.
that bit,
Yeah.
and then
Yeah.
CTD onto that.
On that to that big plume. Yeah.
Okay. And this is coming up at 6.
Whoa! Look at that.
This is fun, huh?
Yeah. What is all this stuff? I don't know what that is. This is really, yeah, there's so much trash.
Yeah.
Whoop, we just vaporized the mat, yeah. Or a chimney. Something. Oh yeah. Yeah, wait till you see the big ones.
They're big ones.
Yeah.
Oh, this is also nice. 1946.
Oh my word. This size
You take a,
is amazing.
you take a picture here
Yeah,
also.
yeah.
I can zoom in a bit.
He's got something in his mouth, yeah. He's a happy fat squid.
I bet you Ross can catch that. Looks like eggs. Yeah, it looks like eggs. It's something like an octopus.
There's some.
Well, a bit of an octopus. It could be a bit of an octopus. Yeah.
I know they are eggs.
Wow.
Maybe they.
Did somebody take a little short video of this?
Yeah, I'm doing it
Okay.
actually. You want to do it? Yeah, you can do, man. This is on this way on. There's 2 cores left. And it's these 2. There's 2 here, right? Temperature probes in there are
Look at that one.
That's insane.
Yeah, look.
Just insane. The
This is
clarity
super-
on it, the
super good,
resolution on it, oh
resolution,
my
yeah.
good. Brilliant. This is the stuff of outreach.
Yeah, yeah.
Here's that one also.
Yeah.
Sure you're not going to
like
those,
them.
you know, those big tentacles that come out when they come.
What is he go? Maybe
I don't know.
So, get a bit closer.
What is that?
Maybe it's eggs or. I don't know if they are keeping it. You know what I mean? Oh, sure. This is another one. It's like a.
And look at that fish piece. This is a short.
No, I'm telling you, we never saw this many animals in November.
You did not?
No, no.
Why?
I don't know.
Yeah.
I mean, it's just
What's the oxygen down here? Is that
20 micromolar.
I can give you an exact figure.
Yeah.
The ctenophore. Those are the ctenophores.
Yeah.
I don't know which one. Man, look at this. They're going together. I'm gonna take that out.
Look at that.
19.
Jason, did you get a short video of that?
Pressed it.
Okay, sweet. Awesome. Let's carry on.
33 micromolar. Okay.
Yeah, that's
And these guys are happy.
and active.
Extremely active. I mean, I'm looking at the number of jellies in the water column.
Oh shit. Oh well. Oops, I
I'll be right back.
screwed up on that one. That's a little pixelated. That one's nice. That's just crazy.
Yeah. But cut that wire right.
Head on to it.
I didn't actually do it.
More bacteria mats all right.
Okay.
Just Ben.
Yes, please.
Wow. Look at those chimneys. Holy moly. God. Okay, we need to get some high def of this stuff. Wow. Holy moly.
This is nice.
This is beautiful. Let's sit right here for a second. Get some video. Are you getting a video clip? I think we found a place to sample chimneys. Wow.
Because they're small.
Yeah.
Break them off, just pieces.
Yeah. But isn't it interesting how they're coated with matte?
Yeah.
Do you see the fluid coming out
Yes.
at the bottom?
There's here fluid.
Yeah.
There's
that's
here
the-
fluid. There's. I saw some when we were coming over this way too.
Nothing
in
smoking,
here.
right? Only shimmer.
No, we saw one smoking this morning. Here.
This was the with the high temperature, no?
Yeah.
Yeah.
Oh, is that the fried egg?
Almost. It's a pretty wimpy fried egg, but I mean, look at the coverage in here. It's just the mats are everywhere.
Yeah. Here you have it also in the middle pretty much.
Yeah.
Did you start a video?
But it seems
No,
like
I did not. There's aquaficales down there. Down here. See that?
Yeah.
Just coming out of them.
Yeah, beautiful.
And then elemental sulfur. I mean, this is greenish. What the? It looks green.
What is that animal down there?
This is a clam.
Clam.
Yeah.
Please.
Didn't have that much feel for it.
That's really, I think it's just showing up green because of the angle. But look how thick that orange mat is right there.
Yeah.
That's amazing.
I think also in between those little.
Oh, there's more of those blobs. See those white blobs over there?
I think those are also vegetal.
No, we don't know what these are. I think these are epsilons. And we collected some earlier. And I think we got them intact. If they stay in the, I mean, they were intact in the sampler, so.
I think the green is a little bit more yellow, no?
Yeah, there's
Is it
yellow,
some green?
pink.
Yeah, but
I
over
think
here-
this is,
oh,
yeah, I think this is yellow. I think this is yellow.
It's just
But I mean, look at, there's also just, I don't know if those are those snails.
Yeah, it is a good one.
Stop. Yeah, look at those gastropods on there.
Oh,
See
that's
that?
really
Yeah.
Oh my goodness.
How cool is that? Can we stay here for 1 minute?
Yeah. I could try to land it if you'd like to.
No, we could, we don't need to land, but if you can hover right here just to get this video of this stuff. Yeah, right. Stop. I'm talking to myself, not you.
Those are out.
No.
And also they're
Oh,
small.
look at the shrimp.
Yeah.
Look at those guys.
I'm gonna go in here and see. Monica, what are those? Are those para-alvinellids coming out of there?
Where?
Wait, what are these right here? See those?
No, I don't think so.
Here, what are
Yeah, I
those?
think,
Yeah,
but I
you know what? I don't know what they are.
No, but collecting them is easy.
You want to slurp some? Just to look at them? I mean, I don't care, but
I mean, maybe you come back in.
yeah, we're coming back here. Yeah.
Then there will be the gastropods and there will be
Yeah.
in it. Then,
Yeah.
then we can just easily don't have to.
All right, I think we're good.
It's nice. There's also some. No, it's not power neither.
No.
Because they don't have so long.
No, they have really,
tentages.
yeah.
This looks completely different. But there are some.
We see a lot of para-alvinellids on these chimneys,
because
but
they like it. They
yeah,
don't mind it hot.
No,
Or
but
relatively hot.
look at that. That's just.
There's also another one in black smokers in EPRs, like a predatory one. This you need, it's like running around. But this is something filter really long ones. Nice.
It's beautiful.
Place. But like the top of those spires is not doing anything.
No. Not now.
Not now, yeah.
Oh, there's flow right there.
Here,
See that?
yeah.
I think we just can't really see it. Is
Yeah,
the
maybe
problem.
it's,
There's here too.
yeah.
If you look close.
Because the tops are not so much
And there's
colored,
flow
yeah.
here. There's flow here. Here. Here.
Yeah.
It's everywhere. It's
Yeah.
coming out all over the place.
But what I mean is like the real pigments, they are more below, so it
Yes,
looks as
yes.
if the top is warmer
Mhm.
and they
Yeah,
don't like it
absolutely.
anymore, no?
Absolutely.
Right?
Yeah. The
So it
biomass
looks
is at
more
the bottom.
bare. I mean-
right. Right. But it's only bare because it's hot.
Right, that's
Wow, look at the backside of this thing. What's that right there?
is it like a little, I don't know.
Little riftia? No. That's those other, whatever those things are. Those other worms. I don't know what they are.
I don't think so. Yeah. You know what they look like? They look like the Princess thread of mussels
Yeah.
for me. But they're
That's
not
true.
mussels.
They're
but
not
they look
mussels,
like
yeah.
this. You know, when you go in the
And now
shallow
you
water,
can
also
really
you
see the
rip
flow
off.
coming out of
And
here.
it's also not, yeah.
They're all flowing. They're just, it's subtle.
So crazy.
But this is a nice,
So beautiful.
Chimney there, really tiny one.
yeah,
Yeah, yeah. And here too.
super. They're super
And
good
the
to
pink.
collect.
Can you believe how many different colors there are? I mean, it's just like, look at these pink guys.
Yeah, pink.
Hey. We collected some of the pink. We collected pink, orange, white, and yellow from one of the other chimney fields.
Yeah.
And it's lovely.
It's just,
Wow. All right, let's carry on. If you think this is cool, wait until we get to Ace's Spire and Rebecca's roof, because did I not tweet that? Am I losing my mind?
Having a problem with the potential stat.
huh?
I'm having a problem with the potential stat.
What's this?
I don't know, there's an error light flashing and it's like has overload signals.
wants to jump in.
Nothing is even plugged in, but then when I hook it up to one of my circuits, it
Okay.
stops.
Should be stationary. Dialed down.
I'm very
Headache.
Or someone, or-
Yeah, I
There's a
texted
chimney thing to your left.
Ted, I was looking at the manual.
The chimney thing to the left, so don't crash into that.
Today when I was doing all my tests with
Should be
it.
on one, there's a big chimney.
So where are we going?
Rebecca Roost.
Alright.
And after Rebecca's Roost, Ace's Spire, and then pick up the Osmo sampler.
You want to move and work on it and like,
Yeah.
Okay.
And then next Riftia collection, we're doing
Yeah,
Do you have
sure,
anything
it's
else?
fine
Maybe
for
we
me.
can have a little more. We just translate
I
it
know
now.
what you need, I know
Yeah.
what I
Or
need, so it's
translate
not
it, or
really,
we don't-
really
Okay.
missing.
We're good.
I
Let's just get up there
Yeah,
and
try it.
that ORP1 is a good bit of elevation, so
We skirt it?
If you
yeah. Or just fly over it.
can just 15 pieces at the most, depending on how big they are. No?
Yep.
Because, yeah.
Okay. I'm gonna go try to
Yeah,
fix
try
the
to-
equipment. I'm like getting down to the wire.
I don't want to try my pump anymore because then it stops working again. It's
All
like
set. I mean, I was gonna.
I'm
like,
set for 2 weeks already, and then 2 days ago I switch on the pump not working. Now it's working.
I've never used a potential stat before, so.
Yeah, try
it
to
might be-
figure it out.
We couldn't really do one because we had them.
How far is it? I see.
It's about 10 minutes.
Okay. Okay.
Mandy, do you have an idea when the sub might come up?
I think
Yeah.
7:30, 7 or 7:30. Probably more towards 7. Why do you need more time? I think I have to be on deck before 8,
Okay.
but I can stretch it as far as possible.
You need to separate the rift anyway.
Yeah, and we got to take
And
awesome
then
video at Ace's Spire and get the Osmo.
Yeah.
Whoa, what is that?
No, I just broke this. That's how we need to do it. We're gonna take a closer look at that?
Nah, we're good.
And when do we meet then?
We're gonna
Like
meet
while
during
they-
while it's coming up. So whenever it leaves bottom, we have about an hour and a half. So the meeting will probably be 6:30.
6:30.
Yeah.
no, I just change my mind because
Alright, just make sure you see the bottom where it's a bunch of stuff right there.
It doesn't matter.
Alright,
We're all
leave
the
the
same.
slide
no,
over
no,
there.
no, I'm sure that I just changed it because if I write oops,
Want me to sit
it's
still?
already done. You're
Alright.
correct. They try
Key.
to put the
Bottom
ball
to
inside and it looks
I don't know what just happened there, so we're gonna continue on.
Yeah. We hit something.
No, I think
Ah.
I just stopped.
Ah,
They
gotcha.
just caught up with me. They were like 5.5 meters off the seabed.
Yeah. Nah, we're not gonna hit anything. And if we do, ooly dooly.
Alright, see that? I can try stopping again, but alright, hold on, there you go. Bring it in more.
That is a lovely picture. Look at that. They're both like,
Ready? No, hold
it's just gorgeous. I don't know what that is. It looks like an octopus, doesn't it? It's like the suction
Either-
cups on an octopus.
Right, either these or eggs. I cannot think of anything else. But why should it keep food there?
Yeah.
You
But
know?
see that?
Oh yeah,
I don't know if-
that is okay. Then it was eating. Maybe.
Yeah. Octopus? I don't know.
I'm not sure. Look, if those suckers are like this big, I mean, then I
Whoa. Yeah.
cannot think that it
Yeah.
can eat it.
Dang,
it's not
there's
that big.
another.
What do you want? Turn off like 6 off. I'm gonna move way up.
Jeez
Take a
Louise.
look at it. You don't care about? Yeah, thank you.
I think I marked where it is. I think we're all right.
Yeah, we got so much stuff on it that when I stop it all flies up. That's the problem. Alright, so that's my double. Still 6. Yeah.
Okay. Rebecca's Roost is a mighty big spire. So, and it's pretty spectacular. Have you seen this before, other than video?
Pictures?
Yeah.
No.
Yeah.
Alright, so based on the map that I have, there's going to be a bunch of features all over. So I'm going to come down to get a better view. You can all stop. No, stop the one right now.
Bridge, we just updated your position.
New waypoints, thank you.
Jason, if you need to take a nap.
I'm good.
Okay.
It's kind of hard.
Yeah, it's kind of hard. It's kind of hard to. It's kind of hard to sleep on these things, you know. I'm just like, when am I going to take a nap today? It's like, it's not going to happen. Because I really want to see the CTD going into that big giant plume that we found. So
Too much.
I'll go to bed around midnight. 1 o'clock. 4 hours. It'll be okay.
Appreciate it.
Trying to go to bed last night was a mistake. see here, there's just the upper neck pressure line. So you can sort of pick and see what you want. These are quite large. I think you'll find smaller ones at this other side, up high and higher. But look, yeah, it is. It is. Good deal. We have a question about the color, and the colors are due to the pigments in the coloration of the microorganisms, and they have different things like carotenoid pigments that are bright orange, so that's why they have the white versus orange versus yellow coloration. Sometimes the yellow can be elemental sulfur as well.
Maybe they are not, if you can look that up, this is difficult to call them because it's very, you know, we can up, but if you
So we're collecting tube worms right now, and it's a bit of a challenge because they need to retract into their tubes before we collect them. So we have to give them a bit of a scare with the manipulator and then pull the tube out, recovering the tube and its occupant. So now we're pulling very carefully, trying not to break the tube or pull the entire cluster, which is what I think is going to happen. Yeah.
Looks like you get
I mean, we were getting the entire cluster last time just by grabbing a couple of the tubes.
Yeah, sometimes. Wow. Okay.
Keep going.
Keep going. Keep going. Keep going. Going.
I mean, you're going to get like 10 worms or more.
This is good. Just put
Now
it
you can
away.
grab it by the bottom and put it in the bio box, right?
Because I like the rock anyway below.
Yeah.
Okay. 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 This is gonna fall if you're.
Oh, yeah. Yeah. That's awesome.
Oh my goodness. Yeah, yeah. Go.
So that's an excellent collection. We got, I mean, probably enough.
No,
Yeah.
yeah. Let's see if it'll fit in the bio box.
Yeah.
Calculate how many there are. We're gonna have our work cut out for us tonight.
I expect every animal to be analyzed. That's pretty amazing.
I'm working on it.
It's enough for everybody on the ship. One on the table, on the plate. You know.
I don't know if it's gonna fit.
It's going to fit.
Can we go?
I couldn't look.
Ray does not want to open right now. Three's not opening. Can you get into 4 open? Please go over 4. Okay.
Can you open it with the other manip?
Well, all I got to do is just change some hydraulics.
Yeah.
I think that will fit into the 4.
Don't think so.
I think I'm gonna need to ready some more dissection sheets.
Don't drop it now. Down the abyss.
Or over the front porch now.
Does anybody want to sample that mat when I bring it up?
Yeah.
Yeah.
That's Dirk's. We can get the map for Dirk. It's perfect. It's a lot.
Does he want from several spots or is he?
Yeah, we're gonna get him a bunch. I mean, he only asked for one spot, but we.
You
But
good,
we
right?
have to put open both of them.
You want lowers on? Give us a second real quick. You want the lowers on?
Oh wow. Is that the divider in between P3 and P4?
No, it's just a 3. No, we need to change the hydraulic level on the heat or whatever.
I think you can get it all in there.
Actually,
We don't want to stress them and bend them, right?
Are all the cameras recorded?
Yes. Yeah, you might be able to just slide them right in there.
I think, does it need to be positioned the other direction so the tubes aren't being?
He's gonna
Open that up and move them over.
Give us a second.
So they, right now it's just so they don't fall. So they're totally stable. We're gonna open the other bio box and then
He's just gonna
position.
take the arm up there and just get it up brushed in.
Oh, I see it from the other direction.
They should fall right
I
in.
think these are smaller.
they're very small.
They have to be
Yeah.
small, yeah.
Yeah.
Oh, can you grab that
A
and pop
lot
that in there?
smaller than that.
Too small?
No, it's good. Huh? It's good. These would have been much better for my
They would have been
experiments
happy in
on
the
the
small bio box as well.
What?
They would have fit in the small bio box.
They fit because it's only more pop.
Yeah. That's so great. That's so amazing. I'm gonna- At the EPR, I have to struggle to get worms this size.
They're all over the place here.
The larger ones don't put on my pressure vessels, so.
Yeah, yeah. Beauty. Well done.
Well, super. Very good.
Amazing.
Awesome.
They have, and also they have enough water. So
Do you want to get a water sample here? You sure?
I cannot.
I mean, we can do chemistry for you if you want chemistry done here.
Yeah, it would be nice
Yeah.
to know what this.
Yeah, can you,
Niska?
yeah.
Sure.
You think that there's a rock on hanging on that stuff?
A what?
A rock below? Is it hanging on that? What you read?
Maybe.
I think so. There is some substrate under the
Yeah,
worms,
I really am curious about. For your
what?
babies.
For babies.
Yeah. So
Niskin 1?
So on the panel right here, it goes 1, 2, 3, 4. It doesn't show that.
Which, the bottles aren't there.
Yeah, the bottom.
Yeah, I see it. It's etched in. Okay.
Alright, look it up, Cody. Go ahead. Fired.
Alrighty.
You have to start at fire. Oh, fire. Yep.
Oh, we don't have Niskins on here.
Is that right? Is that WD-40? Oh, come on. These WD-40 gives cancer. Or it costs. Alright, anything else you want to do here?
Nope.
floating plume.
Oh, I think that's Matt.
Nothing else to do here, or?
Nope, we're done.
Just to confirm, that was bottle 1.
Niskin 1, yep.
Gonna back out, Cody?
Number 1. So this guy.
So let's boogie up to Alvin Spire. Or sorry, the Alvin Spire.
All right, thanks guys. I'm gonna go get ready
You
to
are
sample these.
so welcome. So we need to keep our eyes peeled on the way up there. Let's fly close enough to the bottom so that we can look for mussels.
Yeah, roger that.
Mhm.
The new rings that we got are like a little loose because the inner of the inner hole is larger than the old ones, and there's like a little ring that they like seated around.
Yeah. So the washers are too small.
It's not the washer. They're so I can't take it apart, but underneath there's like a little lip.
Yeah.
That the other ones sat on, so they couldn't move. I don't know.
So it doesn't the lip under there. It's this washer that holds these in, not the lip on here. The lip is.
But it keeps it from moving.
Oh, it doesn't matter if it moves.
Okay.
It can move. But this washer is the key. If the washer's too small, the flapper doesn't work.
In micro mold.
Just to put the old one back on top.
Yeah, that's fine. Yeah, that's absolutely fine. Perfect.
So we're going
Whoa.
up to Rebecca? Flying better for you.
Wow, look at that. Jesus. That is beautiful.
I get it.
Oh, look at the fluid coming out from under here. I'm getting 4K shorts.
Ready, Chris?
Yep.
Gotta go under and have a look underneath that.
Yeah. Yeah, this is not actively flowing under here anymore. It's pretty cool though. Look at all the riftiness. That's... Wow. That's... Oh, look at that octopus.
Still image.
Yeah. And we got 4K video going too.
Oh, look at the tubes.
Yeah.
Wide,
Yeah. Yeah. Oops. There's flow there too. So we're just video documenting this area before we head to our next target.
Oh, yeah, yeah. Alright, going over to
Ace's Spire.
Rebecca Ridge?
Yeah, that's where we were.
That's where we're going, or
We're going past that to the next target, which is Ace's Spire, and I believe we will fly over ORP target 2 on the way there. So just beware, that's about a 2 meter, 3 meter tall tower off the bottom. We do want to fly as close as we can to the bottom to watch for mussels. Yeah.
Where's the CDD sitting in there? Or the inlet for the CDD?
the CDD is on the starboard side,
Uh-huh.
up top. If
Yeah.
you're looking at the ROV,
Yeah.
you're on the left side, up in a little cubby.
So it's on the other edge than the CDD, than the Niskins, for example.
Yes,
Yeah.
yes,
Yeah.
exactly. Yeah. Put it underneath.
Yeah.
Sucked up to the flotation, so it's protected.
Uh-huh. And when you sit on a structure like during the sampling, so the distance between the CDD and the structure is more than 1.5 meters, right?
Yes.
Yeah.
About 2 meters? 1.5, 2 meters? Roughly, it's about the same distance from the Niskin to substructure.
Yeah. So it's the intra-water body down there. It's like lower.
No, yeah. I mean, the oxygen minimum zone is anoxic. So from 400 to almost 900 meters, no oxygen. Goes back up to 20 to 30, stays there. Doesn't go any higher. It's bizarre. How low oxygen can the mussels handle?
I have no value in my mind, so I have to look it up.
Yeah.
And I'm thinking that this is a severe point.
Maybe this is what regulates their abundance.
Or all the other animals that are there.
Yeah,
cope with the same
yeah.
problems, so-
Yeah. If there's clams, I would think the mussels could survive. Huh?
Yeah. I mean, also the larvae, they must be able to enter.
Yep.
Is this the plaque memorial?
No,
That's here?
that's Pescadero.
Pescadero.
Yep. So there are rocks all around. There's hard substrate everywhere. Carbonates. If there's squid swimming around,
Yeah.
there should be.
Everything.
Yeah.
But squid can take a little more than pickles.
Or these
Yeah.
fish also. This guy.
Yeah, he's happy. Yeah. I've seen tons of clam tracks.
Oh, by the way, Jared, I don't know if you noticed.
Standoff.
Covered. I haven't been using it. I don't use it.
We saw a squid with ice.
Please love to post for the camera.
Yeah,
How about this
it's
one?
crazy.
Yeah, this is still low.
Look at this.
I don't use it anymore because it's not reliable at all.
Yeah, the eating an octopus or something like that, sir?
I think. I mean, if there's a piece of
Something like looks like egg.
yeah, look, see that? I think that's the end of a tentacle.
I'm going up to the northeast.
Mhm.
Yeah, I gotta go to that next waypoint. Right? We're going up to the northeast, right? To the next waypoint.
Yes, right there.
There's more.
We want to watch for mussels and. Well, we're gonna. I'll write the worms down.
Bridge, ROV control. Got a new waypoint for you.
Wow.
Bridge, new waypoint. Thank you. Thank you, sir.
That's bright orange. Look at that. This might be OR.
Could be sponge.
Yeah, it might be sponge. What is that? We don't know. We're looking. Let's get a close up. This is that pink pigmented. I don't know what that is. Do you know, Christian?
Yeah, it could be. This is what I mean. This could
Yeah.
be sponge.
Yeah. Yeah.
No. We'll get it done. 4 hours.
Yeah, I'm making a little video right now. That's matte. Look at that. That's not a sponge. I think that's matte. See that? We collected some of this before, and it was matte before. If you look down at the when we suctioned it, you could see filaments. See that? That's filaments. You see that right there? That's filaments. Yeah, look right there. See that?
Yep. Yep.
It's matte. Wow. That's that is really, really interesting. Wow. Have you ever seen pink veggie or pink-ish?
No. No.
Yeah, me neither. Yeah, yeah.
Oh, Avina's there.
Mm-hmm. Yep.
Anything exciting you want to slow down?
No, I think we're all right. We got a good video highlight. I'm gonna get a little bit more of that orange mat right there. Because these. Yeah, let's just. I got the video shooting right now. Let's get a little bit of that. Wow, that's beautiful. Orange Vegetoa. Lots of different animals in this picture. All right, let's keep trucking up there. Trust me, this next place we're going is gives spectacular a whole new meaning. I appreciate it. So the latitude and longitude, somebody's asking about that. It's on the bottom right-hand side of the screen. If you look down there at the bottom, the lat and long are listed. We're at 27.0111 north and 111.4067
On their
west.
screen, it's on the bottom left.
The bottom left?
On their screen.
Oh.
See up there on the YouTube feed?
Okay, so on the YouTube feed, it's on the bottom left.
Bottom left.
That's a big.
Oh, yeah. That's right, yeah. I forgot he took it off.
Oh, so there's no lat and long? So I just gave you the lat and long. Okay. Wow, that's pretty spectacular.
Maybe was that Riftia that we passed just a minute ago? Was that dead? Before we got
Some of it was, yeah. Jesus, this looks Martian. This is just, are those okay, wait, I gotta, wait, so slow for 1 second. I just want to see.
So tell me where you're going.
Right there, right back to that rock with the, I want to see if the,
Hold the camera?
yeah. I want to see if that's just, yeah, that's just Vegetoa. It's just spectacular Vegetoa. Let's stop here for 1 second and just, yeah. Keep thinking we're going to see some mussels hiding somewhere. That is just gorgeous. Wow.
Do you know what this is?
No, I don't. Let's try to get a close-up of that. I mean, it might be mineral. Yeah, yeah. I'm trying to get right here.
Not necessarily, no.
Could that be sponge?
Could be.
Possible. Look how big those filaments are. My word.
This is something that we could sample with a little box that I have with a lid.
Yeah. Yeah. We're coming back here.
It's not on board now.
Yeah. Yeah.
Something at the bottom corner there that's shining. See that? No. Right.
Here.
Right
That
there.
is I think that's one of those scale worms whose name I keep forgetting. There's a hairy gastropod. See that? That's as far in as we can go, but that's pretty amazing. Pretty cool. I'm gonna hold it right there. Is that what you're talking about?
Yep.
Scale worm. What do you think that is?
Oh, Izzy. Izzy's on? Hi, Izzy.
Hi, Izzy. Hi, Brandon.
Do you know what that is?
No, could be
An anemone hiding in there somewhere?
could
Tentacle?
Be, could be.
Because there's another tentacle
there are
here.
others here, yeah.
Here's one here. Oh, photobomb. Here's another tentacle here. We saw these before. We could never figure out what it was. I'm gonna pan out a little bit. I've been 4K'ing for a long time now. Oh, that was a cool. Yeah. Yeah, they're so cool. Yeah, we're good. Let's keep heading up there. What are we doing on time? Oh, there's a sponge.
Got another updated waypoint for you, Eric.
Sponges.
Thank you.
Probably. Oh, yeah. Alvin excrement.
Hello, Izzy. This is Cody and Jared and Chris Ingram. We are piloting today. Thanks for joining us, and hi, Brandon, as well.
Yeah, two pieces, like, well, not two pieces, like half.
How far of a run is that? About 15 minutes? I think it's about 200 meters, if I'm remembering right.
What, 300 meters?
Okay.
Away,
Yeah.
So 30, 40 minutes?
Oh, okay.
How fast do you want to go? You want to go as fast as possible?
Yes. Because we have not a lot of time left. But I want to stay where we can see mussels if possible.
Can you move more lighting? I got look at YouTube chat. It's that window, YouTube live right here. No, top right corner, that window hiding behind everything. This one?
No. See that little small window box?
Oh, I got you.
Yeah.
Oh, expect that.
How far are we off bottom?
2 meters.
Yeah, let's get a little bit.
Going downhill.
Yeah. See if I can get. Yeah, that's pretty good. That's pretty good right there. Sponges. Yeah, there's a clam. What's that right there? Rock.
Looks like a clam.
Is it? Can we stop right there? Hold on. That might be a mussel. No, it's a clam, I think. Can we zoom in right here? Yeah. Yeah, clam. Can't tell if it's alive. Lots of gastropods. What are these things? I don't know what that is. Okay.
Is this the same that we classified as trash?
Well, we figured out that it wasn't trash.
It's not.
It was not trash. Well, there was trash in there, but it was obviously they have little white thread. Yes, little white. There's some sort of worm.
Corals?
I thought maybe they were corals, but they've got what looks like fleshy white at the end, or pinky white. Somebody who knows something about corals. That's oil chimneys. I marked the spot. Can you drop a waypoint right here? Thank you.
What do you want to call this, Mandy?
Mat with oil chimneys. Or mat with chimneys. We'll know what that means. Here's a lot of shell hash. Let's take a good look here. So slow a little bit. Well, that's interesting because that looks like whatever that stuff is. Is that clam? That one right there?
Zoom into this one here.
That actually looks a bit different shape.
This is clam, different
Yeah.
shape.
Oh, is that moving?
Yeah.
Wow, look at that. Hold
Look
on.
at the speed.
He's like a marathon runner. There's a lot on the backside. Can we keep going a little bit ahead, looking on the backside of this feature to see if we see any? This is so weird. Between Rebecca's Roost and this spire is where Andreas thought he saw mussels. What's that?
This is the same
Yeah,
as this. You
yeah,
see the
yeah.
fingers here?
Yeah,
This is some, looks like ahas.
Huh. Whoa, what's that?
Keep going.
Yeah, let's keep going a little. Yeah, keep going slow in this area. We're gonna take a good look.
Facing the opposite way now.
Yeah, let's turn around and go the other way. Yeah. This is just
way too muddy for
yeah,
for
yeah.
mussels.
As we approach this other area, it's very rocky. We are driving around along the edge of a fault, and at the end of the fault is a pretty spectacular series of towers and pagoda-like structures. We should be there in about maybe 5 minutes. Now we're picking up the hose. There's another octopus. We're picking up hard bottom. There's another one. Are we getting a good return on the Spire, you think?
I think so, yeah.
Okay. There's another octopus. Oh no, trash. God, look at that. Can you take a picture right there? Look at that octopus.
A bucket. Hey, it's frozen.
Yeah, 5-gallon bucket. Oh, Elsa, look. An Elsa balloon. That is terrible. Oh my God.
Let's look at cool nature. This is now a lot of octopus.
Okay, this may be the bottom. Okay, we should slow down. What we will see in the beginning is a bunch of sponges. Okay. And, okay, sponges. There should be a cave behind. There should be a cave right over there. Cavern. It goes on the back side of this rock. Actually, this isn't it, because it didn't have an anemone on it. Do we think we're offset here, or maybe not? Maybe.
It kind of looks like what you were talking about. It's a little cave right there.
Yeah, okay. Maybe. Not really. It should be, we should see a bunch of sponges fairly, okay, that's the backside fissure, and there's the octopus. This is the fissure. Okay. Yeah, keep going around and then start going up. Real slow. Because we did not get really good video of this. We got some at the very top, but I'd really like to get the whole kit and caboodle. God, that Osmo sampler. This is Ace's Spire. We're going up Alvin Spire.
Alvin Spire.
Yep. Here starts the tube worms. Okay, let's slow down. Wow, is that a...
That's a huge.
Yeah, these are old tubes. The live ones are on the fissures.
Start coming up?
Yeah. I think we might be on the back side of it. Or we're on the port side of it, I think. So the venting fissure is on the starboard, I think. Yeah. Yeah, let's go over to the front side. Now we might get some really good reflective overlays here. You know, the overhangs with mirror. There's one up here, I think. Right here is an underlay, and probably here too. And on the other side, around this bend, is more.
I got a chimney right behind me.
You do? Oh, yeah. Oh, okay. That's the big mama.
That one's tiny. One back there?
Okay.
That's a little bit.
Yeah. All right, so let's...
Okay, that one has a little bit of shimmer underneath it.
Oh, yeah. Oh, yeah, and flow on the edge. Let's try to get some good video of that. Does this guy have flow under it?
If you hear me with lighting, I got some of the little lights.
Oh, yeah, there we go. Oh, that's not flowing. We need to get some... Can we do some video capture here? Yeah. It doesn't matter. Let's get the, let's let this clear a little bit and see if we can get this on video. This is what we didn't get last time. And I think it's pretty cool, possibly.
We don't put nothing inside the trash. We don't put nothing inside the deal.
No, the main thing is somebody else's face.
Oh yeah, there's the shimmer. Oh yeah. Oh, if we get under it, we can get it. Look at that. Right.
That's what you want to see right there, right?
Yeah.
All of our lights on right now, Cody? Thanks, Cody.
What's the place called?
This is Alvin Spire.
Okay.
We're on the back side of it right now. Is that? Can't tell. See if that's Aquaficales under there, or if it's just a reflection. I think it's just a reflection.
You mean the white stuff?
Yeah, I can't tell if that's fluid. See that?
Yeah, that I see.
That's the fluid reflection. Wow.
That's what I'm trying to get lit up.
Oh, you see this here?
Yeah, that's what I.
From here. It's
Yeah,
going
yeah,
up here, it's
yeah.
trapped here again.
Yeah. That's really cool. Stay right there for a second. Wow, that's a good one.
That's really nice.
Let's let it clear out and yeah.
Darsen a little bit. I need more line, Cody.
It's like a deep sea snowstorm.
Yeah, bro, you have bacteria.
Yeah. They're albanellas. Is that's paraalbanellas, isn't it?
Yeah. Throwing out just like crazy. Should be.
I'll try to get that view one more time. I'll try to get another one.
Oh. Yeah, maybe let's try to go down there again. Oop-a-la. Oh, there's another.
So here there's
Yeah.
nicely in the middle.
So let's slowly move around the top of the feature. See if we can find that ledge where we got the fluid flow last time. I think it's around on the other side. And I have no idea how big around it is because we didn't have time to go around it.
Question whether or not the organisms are being able to get any energy from the sun and evolve to the point where it's strictly from whatever mechanisms they have.
Yeah, they're strictly symbiotic and riftia, unlike some other organisms. It doesn't have a gut.
No mouth, no gut. When they're adult, or when they tiny little babies, when they settle, they do. And then they pick up the sugar, which is just one species, and then they lose their gut.
Yeah, this is
But
this,
yeah, this is.
The
If you
audio?
pull here, then you have.
the whole thing comes off.
It's
Yeah.
like.
Is that an?
about
Yeah. Look
yeah,
in here.
it's about like 2,000 specimens per square meter. They can have easily. It's just what is so funny. What the lymphocytes in EPIs, the polynoids here, they
Yeah.
sit like if you don't look closely, it's like.
Yeah.
Look completely embedded.
Yep.
in
Yep.
that
No,
white-
that's what I was saying. I mean, they're just, you just see the tube sticking out.
Yeah. It's like bacterial takeover.
We still got to go down here. There's really cool stuff on the other side. So there should be a pretty massive venting field somewhere on the other side of this rock, assuming we getting any temperature hits?
I gotta get my look.
You see another field? Let's go check it out. Oh yeah, this is that crevasse.
You can't fit in there.
I mean, look at this thing. This is massive. Karthik, look at this thing. This is crazy, isn't it?
Crazy.
You know, I wonder.
Wait till on the other side, Riftia come in and they're growing on the edges of this thing. If this is connected to the other one.
The other view, if I go around the other way, I got Ricky right behind me. The one I can-
We got to find that big fissure. That's where the fluids are spewing out.
What is his name? Alvin? Spire?
Alvin Spire, yeah.
Yeah, this looks cool.
Let's keep going.
Going where?
So, are you getting another hit?
I got the hit. The hit I got was of this.
Okay.
This stuff.
So let's, somewhere there's a pretty spectacular venting feature on the side with Rifty in the back of it. So I don't think this is coming up right here. Yeah.
Oh, that's why I just.
Is that where you just were?
Yeah, I just turned around back.
Okay. So let's go around the edge of this again. I don't think this is the same one that we videoed the other day.
Yeah, I mean, more than likely, it's southwest.
Yeah.
Is that what it looks like from somewhere? To my starboard forward, but there's another field over there. Right here? Yeah, is that another field? Maybe. It's 15 meters away. And that would be southwest of this.
Oh. Yeah, that's.
This is the same one.
Okay. Yeah, I was just looking at that edge, making sure that wasn't it.
South of it.
Yeah.
I got a really big thing right behind me.
Oh, okay.
Nope, this is.
Okay, I don't think this is it either. Let's keep going around on the starboard side. Let's go around it. I don't think this is it though. Nah, this is too small. Yeah, keep going. Okay, this is looking more like it. Up higher, I think. Yeah, there's the sponges on the bottom. See that?
Yeah.
This is it right here. Keep going up.
Yep, I see it.
You see what I'm talking about?
I got it in second.
Yeah. Look at these guys. It's crazy. This is I think yet another one. Maybe we'll see how high up it goes.
Yeah, they are completely embedded.
Mhm. Yeah. Maybe it's over here. This is just. That's what I'm saying. It just goes on and on and on and on and on.
Nothing against it.
Yeah. Oh, that might be it right there. Maybe.
Wow, this is pretty.
Isn't it beautiful? I don't think this is it. This is yet another one. Can we go a bit to the port? Or just go around the edge and fly around that other side? There's got to be more.
Sonar agrees.
Yeah. I don't think this is the venting feature that we saw. Nope.
Vote man, damn.
You can spend a
There's
long
more.
time-
Look, see?
Yeah, it's over there. I think you can spend a long
back
time
where
to
we were,
understand all
right
that.
there. We've been right there.
You have been there?
Yeah, we've been here before.
Have we?
Yeah.
Okay. Yeah.
Awesome.
I mean, so I can
Look
go.
at the yellow tubes.
Yeah, that's crazy.
My starboard, I'm thinking my starboard. Stuff up on my starboard, right? Starboard. Yeah. Unless that's behind you. It's just such a
Yeah.
Oh, that right there. Get back there.
This is what we found on Dive 5000, but we didn't really have time to sample it properly. Is there more out in front of us?
Off to the left.
Yeah. Yeah. Hello, Veggietoa. Yeah. Veggietoa snowstorm there.
Hmm?
Okay. Nope. This feature that we're looking for is quite tall. And okay, there's, oh, this has to be it. Alvin weights. Okay.
Alvin poop.
All right. Yeah. Keep going up.
I'm coming at this a different way than we did before.
Okay. So you're going to see rifty, then all of a sudden iron sulfur chimneys that are just spectacular. There's some flow right there. See that? And in here. Okay.
I think I've seen, well, tiny ones, but a lot of them, right?
There's a bunch of them, and there's a whole side of. Nah, that's not it. Let's go around this thing all the way around. I think we're on the back side. I mean, the area that is super hot has map behind it. I mean, it might be to the port. This looks like what's behind that venting feature. Try a little bit to port. It's either in front of us, straight ahead, or it's to port. Because there was a tower with Matt and Riftia in the front, like behind the feature. Okay, there's some flow right there. But I don't think this, maybe. Let's keep going around. Maybe this is it. Maybe. Were we here before?
Looks like it, yeah.
Okay.
Where am I smells from?
No. Okay, let's try going a little bit to port. And down a little bit. I don't know. I don't think this is it. Just try to go down on the face. Turn it back to starboard a little bit so we can face it. Go down a little.
Oh, that's quite steep, huh?
Yeah, it is. But this is not. I mean, we have to be near it because of the Alvin weights. But we moved before we dropped weights from that Spire. We didn't want to drop right on top of it. So.
Steel?
Yeah.
What did you say about stupidity earlier? Regret.
Maybe. I mean, we saw sponges and then Riftia kicked in pretty quickly. Yeah, this is not it. This is dead area. Let's try back to starboard, like across, maybe this way, that line in the middle. Yeah. Are you getting any kind of that hit to starboard? Have we been right over there? Have we been there yet? That's where we were before.
Another on the further to starboard.
Okay. Yeah, let's keep going this way. Just look at this edge. Yeah, this is not it. This is so bizarre. Low field. Now this is the ledge that's in the video with the... I never imagined that would be hard to find. Some more orange vegetoa. Yeah. And we had about a 20-meter offset before. So it would be right in there.
We were southeast of the last waypoint, and we were at whatever her name was.
Oh, here we go. I don't think this is it either.
You're facing this way. Fall on this big one right here. We have a few big hits right here. I would, but we're facing this way. Camps around.
We're going to be on deck at
Maybe a little bit before. 8 p.m. Yeah, minimum, a maximum of 8 p.m. Probably before. No, nothing out here, huh? Okay. I really wanted rocks here. Let's go at it from right along this line. So the site we were at before has mats that are sort of a vinaigrette color. This area is more characterized by iron, sulfur, minerals chimneys, and these chimneys are overgrown by Riftia, tube worms, and other organisms, microbial mats, and a pretty wide diversity of invertebrates. See anything?
No, I just had to turn.
Yeah.
Had to get the turn out. I'm not gonna go over where. Over there now.
What's that? I'm hallucinating mussels everywhere. Is that a mussel? No. Bunch of clams. Those are clams, right, Christian? Is Christian in here? Christian, are those what? Your clams?
Sure.
Oh, that's a big one. We were coming from the Osmo sampler site, and we had a hard return on our starboard side. That's how we found this place.
There's something here.
Yeah.
That's where.
Oh, okay. No, that is where we were. Yeah. In the middle of those two things? What's the distance we're talking about between the middle? Yeah, that's not it. Totally not it. Oh, okay. Ah, that's it right there. Holy cow, this whole area was venting like crazy before. This has grown up. Oh my God. That was like up to here when we were here in November. Okay, let's back off and get really good video because we can get a, if we size that up, we can get a growth rate. Wow. So this is the ledge where the venting fluid is coming out. I knew coming up that line would find it. Wow. That is just so different. The chimney's much taller and the flow pattern has changed.
Interesting.
And it's cool because we've got some video so we can do space for time and compare. It all looks pretty similar.
Can you stop? Are you recording or?
Yeah, we're recording.
Oh, sorry.
Yeah, this is it. God, that looks so different.
See that too?
Yep.
Funny again.
Mm-hmm. Oh, look. Wow. Let's try to get under that. Yeah, let's hang out right here. Hold on. Can we hang out right here? Yeah. Oh. Wow. Wow, look at this. Yeah, we're going to sit here and let this clear up because this is spectacular. This is what we couldn't do in the Alvin.
Yeah.
You just can't maneuver like this.
Hmm.
Look at this up.
Did that rock break off down into the right?
That's what it looks like. You see what I'm talking about?
Yeah, I do. The whole ledge broke off, but let's just chill because I think we can get. Yeah. Because we can catch the under here, and then just move. Oh, look at this.
Show me that piece that broke off how it grew. With
Yeah.
The holes
Yeah.
in it.
Can you? We have any more light we can throw at this?
Up in that direction. Let's sort of like faces down. When we come back, we'll have to
Mess with the camera
We'll
before
point
this to make it
something
look right for you.
If we hit this at the right angle, I think we can catch both of these shimmering underneath.
give me a second.
Yeah. Perfect. Yeah, hang right there. That's awesome. Wow. This is just amazing. My goodness. I'm going to start another 4K clip. Yeah, that totally fell off. That's just incredible. Wow. It's hard though. They're different levels.
I'm just trying to get both the ripple at the same time.
go back up.
Oh, super nice.
Can you go back up a little bit? Yep. These crabs are just like. Oh yeah. That's the source. That's further down than I expected. Oh, that's beautiful. Can you go up a little bit high? Oh, yeah. Nope. Let's. That was paralvinellas. Let's go over to the port discharge area. Yeah. Yeah. Oh yeah, that's awesome. That's just spectacular. Yeah, that's great.
It's like Mercury.
Yeah, it does, doesn't it? It's me.
What? Mercury. What? Oh, yeah. You eat the poison chill. One day, go see how it's filled with mercury in here. Yeah. You can let paint up the walls. One big deal? Good old days. Yeah. Finish up?
Yep, I got it. That's fantastic. Yeah, to the port, there's another vending feature that I think is a little is larger and potentially more spectacular. And over there, after we video, we're going to take some water samples as close as we can get into the vending. So I want to get that. So right over in here, we could get perpendicular to that. Yeah. Yep.
Yep. Double decker.
Wow.
Is that hot water food lighter than the sewer water outside?
Yep. So this is an old one that's not actively venting. But up here, we got more venting. Coming up. Alright, let's start that video. Oh wow. Holy moly. Look at that. That's awesome. Look at that. And there's more under here. That's a... Yeah, this whole feature has grown since November. That's crazy. This was not here.
Really?
No. That's just amazing.
There's little chimneys out there.
Mm-hmm.
Yes. Yeah. Probably this goes really fast.
Yeah.
The change.
Wow. I gotta send a clip of this to Andreas. He's not gonna believe it. Because, I mean, this was the big, like, holy moly, look at that cool thing. This thing. Yeah, and that's just, I think that might be where he broke a chimney off.
Ah.
And I wonder if that's what stimulated the growth. I mean, because
But
we,
up there, sure.
yeah,
What do you have
yeah,
up there?
wow,
You see it?
yeah, that's nuts.
You have to look at the top because something
Yeah.
in the top should be also if it's growing up there.
Yeah. Yeah, because
This
this
is
is
sensitive.
yeah. Let's not hit this one. Is that? Look at that mat growing on it up there.
You can take off the top.
Yeah.
It's not so big.
Yeah.
But it's very hot problem. So.
All right. How can we sample the fluid without damaging anything?
Go up there real close.
Yeah. I'd like to get a temperature at the discharge points, not in this tower, it's too delicate, but on one of the ledges.
Yeah, like put it up in one of the ledges?
Yeah,
And then you're going to want to have the Niskin
in the flow, yeah. And we're gonna pull a couple of bottles. That's just, it's beautiful. Let's look at them all. Whoa, get out of the way! Blinded by the light.
You just see that crowd just say, I'm done and jump.
These crabs weren't here either in November. There were no
This is squat lobster.
no, the squat lobsters. They were not here. Look at this mineral right here. That's like pescadero, isn't it? We're collecting a chunk of that rock right there. Don't let me forget that. We're gonna this rock right here. We're gonna collect some of it when we leave. Before we leave. Yeah, the one that is down there is the one that's on the. This is something else.
But the clams are also not on the rock.
Mm-mm.
Only in the sediment.
Looks like I might have caught one inside the net. Oh, no. That was scary.
Yeah, it was. We got on the edge, like right here, and it was about 180. So if we can get under it, that'd be. Just don't want to break it. No, I know. I mean, you can't really. We're not very stable. If it's easier to get on the edge, if that's a better opportunity to not break it, I'd rather just.
Find a nice little stable point.
Yeah. Maybe right here.
Well, yeah, I'm trying to get the ROV stable.
Yeah, I know what you mean. Yeah. There's flow over here too. Look at that.
That's the way it's going.
Oh yeah, this is perfect. Perfect. Yo!
Yeah.
180, 220, 225. Well, it's in the rock now. We're good though. We got 225. So. But yeah, let's not pop it again. We're good. We know what it's. Yeah. It's over 200. Yeah. Yeah, that's perfect. I think that's good. All right. So.
Now you want a Niskin pull.
A Niskin pull, 2 actually.
Right over it.
Right over it. It's pretty impressive.
Alvin is not far away.
Mm-mm.
I like it.
Yeah. I think I'm worried we're gonna hit this thing.
I mean, like, how high do you want it?
I want it actually not high. I want it right over that venting chimney over here, like away from this guy. I think this is gonna get too diluted. Yeah. As close as you can get. So this will be Niskin. Yeah.
What is the other one with the 2?
Yep. Yeah, right there. Is this where we were over?
Yeah.
No. Yeah, this is fine.
Yeah, I'm just trying to come down
Yep.
nice and slow.
Yep.
Keep
Perfect.
it stable. And then I have this camera right here. I'll be able to watch the Niskin spinning.
And that rock that I want is right below there.
And that rock you want is right here.
Nope, it's over here.
That's working.
Yeah. It's the piece that broke off of that ledge. It looks just like the one in the library.
Oh, the broken one over there. Up to the left.
I don't know exactly where, but you'll notice it. You'll see it because it's got the center and the iron sulfide on either side.
Are you gonna be able to see? Okay. All right. Just trying to get the camera.
What happened?
Oh, we have to watch out.
Did you see the blind passenger?
The what?
The blind passenger that we have?
Oh, yeah.
Which Niskins free?
2 and 3. You can fire both of them. Alvin Spire. Yep.
Choose fire. You want another one, you said?
Yeah, 2 and 3. Okay. Alright. Alright, let's back out of there. 3 didn't fire. You can fire 4. So, stop it. 4. 3 did not fire. You pulling 3? 3? Okay.
They're still open.
Yeah. Are 2 still open too?
Two's been fired.
Okay.
Do we need something for Charlie?
She's gonna get Niska water.
There you go.
Let's pull 4 here too while we're here. Tell me if it fires, please. Did that work? Okay.
Fired.
It fired?
Yep.
Okay, so let's pull 4 as well.
No, 4 fired.
Small?
That was 4.
4? Okay.
Three is
Okay, so let's fire 5 then.
there's no fire.
Okay.
That's it.
Fucker. Should have bought my bottles. I have 4 more bottles.
What's wrong with 3?
I don't know. So we have, there'll be so much radium in here that Charlie can measure it in like 100 mils. All right, so let's back off and then go grab that center, that piece of center, and then we're gonna grab an iron sulfur rock. And
So did 3 not fire?
as far as we could tell, no. Say again?
There's a chippy bag on there too, right?
Yeah, no. We can't collect these with that chimney sampler. The rock's too hard. But we're gonna get a piece of that. Do you remember that piece? I think it's to the port and down.
It's right here, right?
Yeah.
It's gonna be right below you.
Oh shit, we're almost on that big spire. Shit, I need to turn this off because I'm getting... Somebody asked if that's mineralization. Yes, that is mineralization. This is these are iron sulfur chimneys. Looks like they also have a little bit of silica precipitate on the bottom. That's a travertine-like deposit. These are pretty amazing features. We're going to go underneath one of the rapidly forming chimneys and grab some of the iron sulfur mineral. Yeah, get that little tower. Yeah, get that little tower right there. Just pop under it. And we're not, are we under it? Yeah. Yeah.
Max Fuller, there was a question about what are the red creatures. If it's the red creatures that look like they have gills, those are the Riftia tube worms.